Welcome to everybody who are here uh, to this discussion in organic chemistry. My name is Anand. Um, Today is a Sunday and it's Diwali Eve, and yet all of you have shown up, and which shows how much importance you give to the work that you do, which whether we know it or not has a huge impact on the education in our country. Uh, I just want to take a very quick couple of minutes just to give you an introduction about this forum. Okay, it is called SPEF, which is School Physics Educators Forum. It was we started it as a physics educators forum, but during the pandemic, we decided why stick only to physics. So we decided to expand our purview and include more disciplines, and that is how chemistry is. And I must say that the chemistry group is very enthusiastic, is very receptive, and I'm a bit jealous being a physics person in the physics. I wish the physics group was as active as the chemistry group. Now we are purely voluntary in the way we function. The anchors that you see here, that you will see here today, those who have come, they are only here because they want to help, because they are willing to take off time from their busy schedules to come and share their teaching learning experiences with all of you, so that you can also learn. You are most welcome to volunteer to anchor sessions in the future also. We are more than happy to see you all come. In fact, the only cost that is involved in this is the Zoom license. And that license is provided by Azim Premji University, is where I work. Azim Premji University comes under the foundation, the Azim Premji Foundation. They've been working in the field of education for about 20 years now, very closely with government schools all over the country. And the university itself is centered on, their motto is education for social change. And when I told them about this forum and the work that we do, they were more than happy to support us. So a big thanks to Azim Premji University for helping in this happening today. Now I will hand over to the three anchors that we have, Sharmista Madam, Poonam Ma'am, and Vijay Kumar Sir. They will introduce themselves, after which I'll just take 30 seconds to tell you how the format of this whole thing is going to be. Right. Thank you very much for coming. We are very glad to have you here. Please feel free, keep your videos on. You can sip a cup of coffee. There's no problem. We are all very informal the way things run. Thank you and welcome. Over to the three of you.
So good afternoon, all of you. My name is Poonam Lal, and I am a retired chemistry teacher. I am not in active service. But I love chemistry, and for the love of chemistry, I like to participate in these programs. I worked for 25 years in St. Thomas Residential School in Trivandrum, where the anchor of this program, Anand, was my student, and that is how we have connected. And it is indeed a great privilege that we are able to have this program where we can share. And as Anand said, it's only out of love of chemistry that we are all here, in spite of the Diwali weekend and in spite of the cricket match. Everybody is here. Thank you so much. And I don't claim that we are, we are just doing it for happiness. If there is any flaw in the program or in the way we present, please excuse us. And we are all open to any suggestions that you might give. So Vijay Kumar sir, please introduce yourself.
Good afternoon, Anand sir, the Poonam ma'am, Sharmista ma'am, and other teachers who have joined for this live session of organic chemistry. Myself, Vijay Kumar. I have 12 years of teaching in ICSE. I work for a Sishya school in Chennai. This year, our school celebrates a Golden Jubilee year. So I'm I'm more interested in teaching this organic chemistry for my school students. We have found a good methodology for teaching organic chemistry. I would like to share those tips and tricks with my fellow teachers who are all from different parts of the country. I welcome you all to this program. Now over to Sarmishta ma'am.
Good afternoon, everyone. Good afternoon, Anand sir. Good afternoon, Poonam ma'am, Vijay sir, and all the teachers, those who have joined us today in this live stream session. I am very new to this session, though online teaching, we are quite habituated with the online teaching, but I am so privileged to get this opportunity to like serve myself, like as Poonam ma'am said, due to the love of chemistry, which will be beneficial to the children. Our main aim, and I think every one of us has the same motto, to share our views. As such, organic chemistry becomes very tough for each and every candidate in the school. Maybe a handful likes, and a major portion, majority of the students like dislike, maybe or unable to learn the parts. So it's very important for us to join together and help each other so that the student body gets benefit. Thank you so much, Anand sir.
Thank you. Thanks again, all of you. I'll just quickly say the format. We are already 10 minutes in. We will have the anchors speak. Vijay Kumar sir, I presume you are starting? Okay, so he will speak, after which we will have a question and answer session. Then the next person, then again Q&A, then the third person, then Q&A. But in between, if you have a very pressing question, please feel free to just unmute yourself. But as much as possible, keep it to the end of the session. Thank you very much, all of you, for coming. Over to the three of you. Over to you, Vijay Kumar sir.
When it comes to organic chemistry, this particular year, 31 mark is asked in organic chemistry out of 70 marks. So approximately we can say organic chemistry comes for 50% of our board exam question paper this particular year, with all the reduction in syllabus. So the focus on organic chemistry is more this particular board exam 2023 we are talking about. So the approach of organic chemistry, when we say why organic chemistry is difficult, people come out with a different answers. When it comes to students' perspective, students are telling different stories, and we teachers face a different kind of problems in teaching organic chemistry. And I did a small research with my fellow students, and with all these years of experience of teaching organic chemistry, the first and the foremost thing that comes to my mind, why organic chemistry seems so difficult, is from the name. Each organic compound, we know there are millions of organic compounds, and each organic compound has a specific name. And we need to address these organic compounds by their names. Okay. Now, with all the facilities in the Zoom, I know each one of your name here. I can call you Poonam ma'am, Anand sir, Suraj sir, Sheetal ma'am, Karthikeyan sir, like that. I can call you by name. So if I don't understand your name by looking at you, if I don't understand your name, there is no connectivity between you and me. So like that, to familiarize with organic chemistry, the first thing is to get familiar with their names. I draw a structure on the board. The students should not read it as alphabets. CH3 hyphen CH2 hyphen OH is nothing but a kindergarten student looking at the structure and calling each alphabet. Are we teaching alphabets and numericals to our class 11 and 12 students? No. The moment there is a CH3, CH2, the student should identify that as an ethyl group. CH3, CH2, C double bond OH It's not alphabets, rather than it is by the name acetaldehyde. So the moment the student look at the structure on the board, whatever we write, the student should relate it with the names. The problem is with how we teach, how we introduce organic chemistry to them. In the beginning of 11th standard, in the introduction to organic chemistry, the basic concepts of organic chemistry sessions, we introduce IUPAC names. We all love organic chemistry. We are all postgraduates in organic chemistry. So what we try to do is, we try to introduce a longer carbon chain. The moment we come to 11th standard, anything lesser than 6, we are not happy. If we give 3 compounds, 4 compounds, 3 carbon, 4 carbon chain to a 11th standard student, we feel that is inferior. So we all give 8 carbon, 9 carbon, maximum 12 carbons. And then too, the fantasy level will increase. Not writing CH3, CH2, the so-called bond line notation will come. And on top of that, IUPAC will give 100 different types of rules. Lowest sum rule, and then comes carbon chain rule, the first order of preference rule, where the methyl group comes, so many such rules. And by giving all such rules, we terrorize the students. The students actually get frightened by all these rules. And finally, after learning all these IUPAC names, what happens? It comes maximum for 5 marks in the 11th standard board exam question paper. That's all. These IUPAC, big IUPAC names comes for just 5 marks in the 11th standard board exam, 11th standard annual exam. With that, the big names are over. It might reflect later in the JEE mains, JEE advanced and NEET exam and all sorts of competitive exam. But in 12th standard, there is no big IUPAC names with the 3 functional group, 4 functional groups are never asked in our ISC. Might be in CBSE, they ask this question. A longer chain, maximum 7 or 8 carbons with some 2-3 functional group, they ask this question. With that, our love of IUPAC name and the students' love for IUPAC name gets over. But when it comes to chemical reactions in learning the conversion of functional groups or writing the equations, if you have noticed in all the board exam question paper, it is never the IUPAC name and never the things that we teach in the 11th standard big IUPAC name. It is maximum 2 carbon, 3 carbon, 4 carbon. That's all. I have seen organic conversions which was asked in ISC at the max up to 5 carbon. I am saying 5 itself is maximum. So if it is lesser than 5 carbons, it is the common names that are much more important rather than the IUPAC names. A couple of years back, one school asked me to give a small brief this kind of course to their students for organic chemistry, and I asked them what is the formula for acetaldehyde. The children doesn't know the formula for relating the formula of acetaldehyde as a CH3C-double-bond-OH to the name acetaldehyde. And I said the IUPAC name of which is ethanol. Now the children are able to tell. And my dear friends, yes, IUPAC name is important, but not for the board exams. In the question papers, most of the time, it is the common name that is more important rather than the IUPAC name. Formaldehyde is only written in the question paper because for you and me, our chemistry professors have taught it only as formaldehyde and never as methanol. Yes, we should know methanol as IUPAC name. Ethanoic acid will be never written in any board exam question paper. It is only acetic acid will be written. Acetic acid, acetyl chloride, acetamide, all these are common names. But rather, we focus more of IUPAC names, the 2 big bada IUPAC names in the 11th standard, and the student thinks every time only the IUPAC names will be there in the question paper. And when the common names comes in the question paper, it is a big surprise for the students. So the students are not able to get the connect between the IUPAC names and the common names. So my suggestion, this is the first shackle that we need to break. teach the common names to our students. Start from alkane onwards. Every functional group, first 3 or 4 members, common names are important. See, common name we can understand like this. Common name means commonly addressed name. My name is Vijay Kumar Prabhakaran. Prabhakaran is my father name. But everyone addresses me as Vijay. Vijay sir. In my school, they call me VK sir. So that is the common name for me. Vijay Kumar P might be my IUPAC name. And no one addresses me as Vijay Kumar P. Vijay, VK sir, that's a common name. Commonly used names are common names. And let us try to teach that to our students, and our students get familiarized with these common names so that it becomes easy for them. And not the simple common names. For example, once aniline plus acetyl chloride in the presence of pyridine, acetanilide was the product. The board exam questioned about acetanilide. For sure, many of us would not have taught the name acetanilide to our students. Acetanilide, let me share my screen and draw the structure. This compound, benzene ring, NH, C double bond O, CH3. When we do the acetylation of aniline, we get this compound. This is called acetanilide. Do all our students know this name, acetanilide, which is a common name? Acetone, all the functional groups. Please teach the common names. I experimented this. I'm closing my whiteboard. I experimented this and I have come out with around 70 common names, including the aliphatic and the aromatic thing. Including aliphatic and aromatic, there are around 70 common names which are asked. Another example I will give you. Anisole is the only name that is asked in our board exam. It is never methoxybenzene. Our children know it is methoxybenzene, but they can't relate it with anisole. That's an irony. So 70 odd names. Start from alkane. Methane, ethane, alkane, no problem. But isobutane, you teach them. Isobutane. 2-methylpropane is isobutane. Methylpropene is isobutene. And when it comes to 3-carbon, methyl chloride, in alkyl chloride, let it be methyl chloride, ethyl chloride, N-propyl chloride, and isopropyl chloride. And in 4-carbon, please teach them N-butyl, isobutyl, sec-butyl, and tertiary butyl. I will focus on these butyls. How interestingly our forefathers has kept these names. For example, this is a N-butyl group, CH3, CH2, CH2, CH2. This they keep as N-butyl. N stands for normal butyl in the normal chain. And then the moment it comes over here, they call this as secondary butyl, sec-butyl. When we teach this common name, teach them what is a secondary group means. A secondary carbon is an alpha carbon, which is a sp3 hybridized carbon, alpha carbon, which is connected to 2 more carbon atoms. Like that you teach. And then this is a tertiary butyl group. This is a tertiary butyl group. I don't want to go elaborate. I'm just telling you some examples. This is the tertiary butyl group. And this is an isobutyl group. This is an isobutyl group. Now this is an isobutyl group. This is an isobutyl. And tell them. Now the children will immediately jump and ask us the question. If there is one isomer which we call as N-butyl, why the other 3 are, all the 3 are isomers, and why they specifically call the 4th one only as an isobutyl and the 2nd one as sec-butyl and tertiary butyl? It's very simple. N-butyl is a primary. The isobutyl is also primary. The other primary alkyl group, they gave the name N-butyl and isobutyl. One is secondary, one in tertiary. So there is some logic involved even in the common names. So this is what we need to convey to our children. Once, so like we started this session, our approach of teaching organic chemistry should be reiterating on all the important IUPAC and common names. For me, it come around 70, starting from alkane, till the organic nitrogen compound. Teach them and give them a test. Give them a test in organic compound, these 70, all containing single functional group, which is going to come in their reaction in their question papers, which you set or I set or there in the specimen paper or in that board exam question paper, the names which are occurring frequently, that we need to expose it to our children. This will take for teaching everything. Don't say that we have already done this in 11th standard. Please don't say that word to other students. A student who enjoyed wasting the whole year of 11th standard, when he or she comes to 12th standard, it is our duty to first teach them, my dear student, please listen, you have wasted 1 year time without learning these names. Without these names, you cannot study organic chemistry. Without knowing the name, without knowing your name, I cannot get contact with you, I cannot get familiarized with you. So learn the names. And after, it will take some 3 or 4 classes to introduce all these 70 odd compounds. Okay, I am not going to tell you which compound. You know, first 3 functional groups, so 3 compounds of every functional group, aromatic names, only the names which is going to come for our question paper, board exam question paper. And once we have done that, we need to keep a test. We need to keep a test to the students. They should get, if you are keeping for a 25 marks, give 25 marks, all the structures, IUPAC and common name that is going to appear in the board exam. Once you have done this part, almost 90% of your students will be thorough in the names. Then only we need to go for the next step. So this is what is my way of teaching organic chemistry. This is what I'm suggesting to you also. Try this out. I'm ending this. I'm stopping my lecture now. If you have any questions, you can ask me now. Okay, I want to ask this question to you. How many of you have done this training of teaching the names before you start doing your organic chemistry classes?
Sir, I am Lydia.
Very good, ma'am.
From Bangalore.
Yes.
I'll do every time. Whenever the chapter beginning, we'll start with the nomenclature. So both the names, common names as well as the IUPAC name, I'll start. Then only I'll go for the classification and preparation and properties. In that way only I'll go. Sir.
Exactly, ma'am. Yes, that's a wonderful thing. But the children should be very familiar with the names. That's very important. So keep a test on naming part alone. This is I'm just adding one more value to whatever you're teaching. Please check that whether the student has understood that you are doing it. We before every chapter, I know you will list all the important names that are coming in the chapter, but whether it has reached to the students, whether the student know the importance of what you are teaching. We are doing our part. The same thing, the student also should know that the naming part is very, very important. That is why my teacher is specifying on that. So give us test specifically on that. This test mark is not going to help him. It is not going to come in the exam, but that will help him to understand the reactions better. Okay, fine. If there are no questions, we'll wait for a minute, Anand, and then Poonam ma'am can start.
Yeah.
Sir, regarding, excuse me, sir. Hello.
Yes, ma'am.
Yes, ma'am. Go ahead.
Yes,
Go ahead.
Regarding aromatic compounds, which are the most common one? Can you discuss once? Few examples regarding aromatic compounds.
Aromatic compounds are all the known ones only, ma'am. Chlorobenzene, phenol, anisole, acetophenone, benzaldehyde, benzoic acid,
Okay.
benzamide, benzyl alcohol, benzyl chloride, benzene diazonium chloride, nitrobenzene, aniline, cyanobenzene, toluene.
Yes.
And acetophenone is important. Why I am telling you? In the ether chapter, see, in nowhere else in our syllabus, they talk about Friedel-Crafts alkylation and Friedel-Crafts acylation. Only for anisole, in our syllabus, it mentioned Friedel-Crafts reaction. They did not specify whether it is Friedel-Crafts alkylation or Friedel-Crafts acylation. When one of our teacher asked Friedel-Crafts acylation for anisole, our students should know the name for that compound.
Yes.
in the ortho position and the para position, the acetyl group is coming and attaching to the benzene ring. It's called acetophenone. But we don't learn the chemical properties of acetophenone separately. But only when the student knows it's acetophenone, he can say that it is orthoacetyl anisole, or like orthoanisole, methoxy acetophenone, para-methoxy acetophenone. So the word acetophenone should be familiar. When it comes to aromatic compounds, the list is less. What I can do is, I just wanted to give this information to you. I don't want to give the entire list of 70 odd compounds. What I did. Probably I can share it. I can share it later in the group, which is 70 compounds. That way, because that should save our time. We cannot discuss all the thing, man. Definitely, I give only some examples here, but I will share the list with you.
Okay, thanks.
So thank you very much, Vijay Kumar sir. It's very important, as he said. One suggestion I had is that to make children remember and practice, it takes only first 5 minutes of your class. You can give a dictation every day. So just give a dictation of 10 compounds and ask them to check each other's work. And you can just take a round and see now, since we have live classes, so there is no problem. We really had a problem when, the last 2 years, what has happened is we have had online classes. And so these concepts which children learn quite easily in live classes, they are not able to. So their basics have taken a beating. Children who are in 12th standard now, they haven't done their 11th standard very well, and they have done it online. And I have seen how children sit online, they don't switch on the camera, they don't write anything. And organic chemistry, the first rule, as sir said, to relate to each compound as an individual, you should know the name. The second important trick about organic chemistry is it is all about writing. You can't do organic chemistry without holding a pen in your hand. You can't just read. When the teacher teaches, it all appears so easy, but unless you write it, you will not understand. So it is very important to insist that the children write and learn. Okay. Now, my part, I feel that once you have done the whole organic chemistry, first of all, what I want to tell you is that our focus right now is on class 12. I went through all the questions which various teachers have sent, and everybody is of the opinion that many of them have said they want to learn about reaction mechanism. So reaction mechanism is another, whole chapter, and we can do reaction mechanism, but that will benefit the students of class 11 and teachers who are teaching class 11. Right now, we are more focused on how to prepare them for class 12, because the boards are now coming. What are the different types of questions which are asked, and how to get ready for those questions. So what I have observed is that there are mainly 5 different types of questions which are asked. One question which is asked without fail is on name reactions. 2 or 3 reactions are given by name, and you have to give an example. So Mr. Ma'am is going to take up that part of name reactions. Then there are questions on distinguishing tests. So that again, 2 questions are there for sure from distinguishing tests. So that also Sir Mr. Ma'am will take and give you examples of what are the possible distinguishing tests, and a few examples of how to write a distinguishing test properly. Then the third part is third question is from conversions. And for conversion, there comes a problem where children are not able to connect one compound to the other. So what I always tell the children in the class is that, most children who are very good in maths and physics, they also don't tend to do chemistry well. So I always tell them, in chemistry, it is actually it is like trigonometry. And you are only trying to always prove the left-hand side equal to the right-hand side. So there are, like in trigonometry, don't you memorize 25 formulae? Without memorizing or knowing those 25 formulae well, you will not be able to connect the left-hand side to the right-hand side. So similarly, don't dread chemistry. Don't think chemistry is all about memorizing. Some memorizing is required everywhere, whether it is physics or it is chemistry or it is biology, all subjects, mathematics also, you have to understand the formula and then retain it and recall it. So same way in chemistry also, you have to take a firm grip on the reagents, different reagents, what they do. So my focus is on different reagents, what they do. So now, since most of you would have finished organic chemistry portions, now you can, take one or two classes on different reagents that are there, and then connect them and help them to revise and keep asking them like a quiz, what does this reagent do? What does that reagent do? And with that, they will be able to use those reagents to convert one compound into the other. The fifth type of question is give reason. So if time permits, we will do that give reason question. Give reason also includes those questions where you arrange the compounds in increasing order of acidic nature or in basic nature or increasing rate of esterification and all those things. So I'll share my screen now. So, so the first thing I would like to say is that, we as teachers, we should first of all be very, very enthusiastic about chemistry. We should love chemistry, and only when we love organic chemistry, we should, we'll be able to make children feel the same way. So the second thing I want to show you is this is the blueprint which I made with the help of the model question paper. And although in organic chemistry, strictly speaking, there cannot be any clear-cut classification of where haloalkanes end and where alcohols begin. All the reactions are mixed up. But roughly, when I try to put different chapter questions, I found that maximum number of questions are being asked from compounds containing nitrogen. I don't know whether it will be the same in the board exam also, but we have to focus a little on compounds containing nitrogen. That is the last chapter in organic chemistry, but nevertheless, this is the distribution. This is 1 mark question, this is 2 mark, 3 mark, and 5 mark question. One single 5 mark question with a choice is from aldehydes and ketones. So I feel aldehydes and ketones is the most important topic. Now what I plan to do next is just take you through, because all of you are teachers and all of you understand these things, but I just quickly want to take you through very briefly through the reaction mechanism. So here you see there is the first thing you can emphasize when you talk to your students and tell them is that organic reactions, they are difference between an organic and an inorganic reaction. And why organic reactions are much more easier to understand and to write the product compared to an inorganic reaction. So first of all, the organic reactions are widely studied reactions. They are slow, so that is why we can find out their mechanism easily. We can predict the product easily. And there is so much work which goes on with organic reactions, because these organic reactions help us to synthesize almost everything that we know today is can be synthesized in a lab. So all the challenges about synthesizing all those compounds which we earlier felt cannot be synthesized in the lab. So all the medicines and all the, see, in fact, when I start my class in organic chemistry, I tell them, you get up in the morning and just think in your mind what all you do, and you will realize that you cannot, your life cannot move a single step without chemistry. Organic chemistry, that your brush, your toothpaste, your soap, your the food that you eat, the proteins, the carbohydrates, the gas that you use, everything the fuel that you use for your car, the pen that you use, the ink that is inside, everything is organic chemistry. So there's no harm in spending 1 or 2 classes in the beginning and telling the teachers about telling the students, making them, enthusing in them the interest for organic chemistry. So the reason why organic compounds are easy to understand is the second point which I have written here. It is that the major part of the molecule of organic compound does not change. The reaction takes place only on the reactive site. The reactive site only the reaction takes place. So a general organic reaction is like this. We should be able to recognize the substrate, the reagent. Right now in 12th standard, don't bother too much about intermediate, but when you are teaching in class 11, you should talk about the intermediate also. So if you understand the substrate and the reagent, you can definitely predict the product. And in most of the cases, the product will be what you predict. So the reason why I'm saying is that explain the general reaction in the beginning and then make the children write the answers, make the children predict the answers. Don't just keep writing the answers one after the other on the blackboard, just make the children predict it. So say for example, in this reaction where the propene is reacting with HCl to give you 2-chloropropane, identify the substrate, tell them this is the substrate. And where is the reaction taking place here? The reaction is only taking place where the double bond is. The rest of the molecule will not change. Even if it is a long alkene, the reaction will take place only where there is a double bond. So that is the advantage of understanding the substrate. So what I have done is I have classified my substrates. This is a little classification that I do, that I classify the substrate into different types. Now, first type of the substrate is which is saturated with non-polar bonds. Example is alkanes. Then you have saturated substrates with polar bonds. The example is alkyl halides and alcohols. Then unsaturated substrates with non-polar bonds like alkenes and alkynes. Unsaturated substrates with polar bonds. So that is aldehydes and acids. And then of course you have conjugated system which is present in aromatic compounds. So once you are able to identify the substrate, you will start looking at the reactive site and you will start thinking about how the reaction will take place. Then I'm just quickly going through these different types of terms that you might like to use sometimes, like fission, bond fission, which can be homolytic and heterolytic. These are different types of reagents. We are going to focus mainly on reagents today. So you know they can be electrophiles, they can be nucleophiles. A common question which many children ask is, the mistake that we make is we say electrophiles are positively charged species. So they immediately come up with the question why sodium is not an electrophile, or sometimes in the question exam I have seen, and even in entrance examination, they say, which of the following is not an electrophile? So sodium is not an electrophile. Electrophiles are basically electron deficient species, which can accept a pair of electrons, okay, which can accept a pair of electrons. Then nucleophiles are there. Then this is about carbocations. This is important because when you are showing a reaction and helping them to learn, they should be able to see whether the carbon is acquiring a positive charge or a negative charge. So you can have carbocations and carbon ions. And then you have, after you can actually talk to them about addition reaction, substitution, and elimination reaction. When is it addition, when is it substitution, and when is it elimination reaction? So this, not going into very deep reaction mechanism, these basic things always help them to learn and understand a reaction and then memorize. Okay, so most reactions, they occur in 2 steps. If both the steps are addition, then we call it addition reaction. If one step is addition and the other is elimination, then it is a substitution reaction. And when both the steps are elimination, then it becomes a proper elimination reaction. So this is the way I teach. I always tell them that my chemistry is a study of a family of 7 A's. Okay, a family of 7 A's. These are alkanes, alkenes, alkynes, alkyl halides, alcohols, aldehydes, and acids. And another A, which is a cousin. And what is this A? I hope you understood. These are aromatic compounds. Okay. Now, in the beginning itself, now that you have finished teaching, you can start this once again and say, in the beginning itself, you can tell them that, you know, these alkanes, alkenes, alkynes, alkyl halides, if you put them in this order, just like, you know, reactivity series, you can see when you go from top to bottom, okay, from alkanes or alkenes or alkynes, you have to prepare acids, you have to use the method of oxidation. And when you go from bottom to top, you have to use method of reduction. So from top to bottom here, it is oxidation, and from bottom to top here is reduction. They should understand this very thoroughly. Alcohols oxidize into acids, alcohols oxidize into aldehydes, and aldehydes to acids. So we are going to use different oxidizing agent. Obviously, the same oxidizing agent is not good to oxidize alkanes to acids and to alcohols to acids. So you have different oxidizing agents which have different abilities to bring about these changes. Similarly, it is for reduction. Acids can be reduced to alkanes, acids can be reduced to aldehydes, acids can be reduced to alcohols, and all these can be done by different reducing agents. So that is where the knowledge or command over knowing the different reagents is very important. Which reagent can bring about what sort of reduction, which reagent can bring about what sort of oxidation. If you understand that, then it becomes very, very easy to do all the conversions. Then another trick which I use is that I tell them, see, alkyl halides are the center of this family. The family moves around alkyl halides. So you should be very, very thorough with alkyl halide, because this connects alkyl halides connects towards alkenes, alkynes on this side, and on this side alcohols, aldehydes, and ketones. So when you are teaching, say for example, alkyl halides, you should first teach them from how to prepare alkyl halides from alkenes, then alkynes, then how to prepare alkyl halides from alcohols, aldehydes, and acids. And similarly, from alkyl halides, how can I prepare alkynes, alkenes, and alkanes? And from alkyl halides, how can I prepare alcohols, aldehydes, and acids? So if I start connecting my reactions like this, the children will start thinking. Now, when I start teaching methods of preparation, they should think, okay, now alkanes. I have already finished teaching alkanes. So they should say how to prepare from. If a particular compound cannot be prepared by one of its relatives, why it cannot be prepared? Or can I convert that relative into some other compound which can be in order finally changed? So always when you are teaching methods of preparation and properties, just keep linking the previously learned whatever they have learned earlier to what you are going to teach. So that helps the children to do very well. Then, so here I have, divided my substrates are all there. This is the description of the substrate. This is saturated with non-polar bond. So if the bond is non-polar, then obviously the reaction, and it is saturated, the reaction has to be a substitution reaction. So they should be able to recall and say which substitution reactions it is undergoing. Similarly, if it is alkenes, then it is unsaturated, and it will undergo addition. If it is alkynes, then again addition. When you come to aldehydes, they are unsaturated with non-polar bond. So again, it is addition reaction, but what type of addition reaction? All those things, if you connect them, the children will understand it much better. Then one more thing which you can use, especially the if not at this stage, because we are now close to the examination, but teachers who are still teaching in 11th standard, for them, this is a little trick. You can, write the reaction. Don't write the product in the beginning. Write the reaction. Help them, ask them to identify the substrate. Then what is the nature? Is it saturated or is it unsaturated? Then what type of fission does the reagent undergo? What type of fission will the substrate undergo? Connect all these things. And then what will be the type of the reaction? So you can teach them like this. And then show different types of reactions. Now I have taken nucleophilic substitution here because it is also there in our alkyl halides. So when we teach them alkyl halides, if we teach them, we have to teach them SN1 and SN2. So there first teach them simple nucleophilic substitution, and then based on the nature of R, divide it into SN1 and into SN2. So like that, you can divide different reactions in the beginning to make them think that it is all logical. It is not memorizing alone. You have to memorize, but it is all by understanding the logic, you should be able to do it. So I have prepared all different types of reactions here. This is a reaction for, these are just different ways to make the children enjoy this. So this is also from, you can see this, how to, this again, a substrate. So what is the nature of the substrate? Then what is, it is an unsaturated hydrocarbon. Then what type of reaction does it show? It shows electrophilic addition. Then you show the electrophile breaking into two, electrophile and nucleophile. So first, the electrophile approaches, and then it forms a bond, and then addition of electrophile is followed by the addition of nucleophile. So like that, we can show, simple animations which children can enjoy and get interested. Right now, it is not about just enjoying it. Right now, it is also about learning. This is a little animation for how the nucleophilic substitution takes place. Chlorine leaves, and then OH comes in. So this is about those who wanted to learn little idea about how you can make the reaction mechanism interesting. But this has to be done in class 11, and that will help you to a great extent in teaching class 12. So this is about reagents. I will anyway share this PPT for your use. We are rushing a little because, as you know, all these topics require a lot of time. We are just here to give you some idea about how to do it. Now, the reagents, there are different reagents. I have chosen some where children get confused. So now that you have finished teaching organic chemistry almost, now you can go back and revise like this. Like, for example, aqueous KOH and alcoholic KOH. Now, children make a mistake now. Supposing it is here CH3, CH2, Cl. With aqueous KOH, right? The product is CH3, CH2, OH plus KCl, right? This is what type of reaction? This is nucleophilic. This is a substitution reaction, substitution. But if I take CH3, CH2, Cl, and I take alcoholic KOH, okay, what I get is CH2 double bond CH2 plus ethene plus KCl plus H2O. Okay, so you get ethene here and alcohol. So this is a elimination reaction. So please emphasize on this. Elimination is brought about by alcoholic KOH and substitution is brought about aqueous KOH. So remember that aqueous KOH always brings about substitution and alcoholic KOH brings about elimination. If time permitted, I could have given you the reason why alcoholic KOH gives elimination reaction. But if you look at 11th standard textbooks, you will understand there is a elimination because of the reagent, which is OC2H5 minus, which is a good base, so it abstracts or removes a hydrogen rather than it attaching to the electrophile. So that is why it is important to emphasize. Then this reagent, this is called a halogenating agent. Now, halogenating agents are many, and of these, most importantly, the questions are asked from PCl5 or SOCl2. Now, what does a halogenating agent do? It changes the OH into Cl. OH is replaced by Cl. Now, this OH could be anywhere or in any number, but if I use PCl5 or PCl3, the OH will be replaced by Cl. So, say for example, if I write CH3OH plus in presence of PCl5, OH will be changed to, so it will be CH3Cl. Okay, byproducts you all know how to write. Supposing it is CH2OH and CH2OH, and I take PCl5. Also, OH will be replaced by OH will be replaced by Cl. So it is very easy to tell the students wherever there is OH, it will be replaced. So much so that if I take CH3, C double bond O and OH, this is what acetic acid. So acetic acid, if I take with PCl5, what will happen? CH3, C double bond O and Cl. OH is replaced by Cl. So you get acetyl chloride. So here also OH is replaced by Cl. So PCl5, what is the role? It replaces the OH with Cl wherever the OH is. In fact, if I take sulfuric acid, the structure of sulfuric acid, earlier we used to have this reaction in inorganic chemistry, now we don't have it, with PCl5. Okay, what happens? Both the OH will be replaced by Cl. So what will be the product? You get SO2, Cl2. So wherever OH is, PCl5, PCl3, SOCl2, what do? They replace the OH with Cl. So they should remember, whenever I have to replace the OH with Cl, I have to use my halogenating agent. Then the next reagent, which is also a halogenating agent, is Lucas reagent. So where do we use Lucas reagent? Lucas reagent is also halogenating, but it is mainly used as a distinguishing test. Distinguishing test between primary, secondary, and tertiary alcohols. Primary, secondary, and tertiary alcohols. So the primary alcohols do not show any change at room temperature, but tertiary alcohols show instant turbidity. But here also the reagent only, what does it do? It replaces the OH with Cl. Okay, so remember, all these reagents can be used to replace OH with Cl. Then I want to tell you about HBr and HBr in peroxides. Now HBr, here I am using it for addition reaction. All of you know these reactions. This reaction becomes useful in 12th standard also to a great extent in conversions. So supposing I have to add HBr, it doesn't matter if you are adding it to ethene, but if you are adding it to propene, it follows a Markovnikov's rule and we get CH3, CHBr, CH3. Okay, so tell them if it is HBr by itself, then it follows the Markovnikov's rule. So MKT product, Markovnikov product we get. But if we have this one, ethene with HBr, in presence of peroxides, then my product is CH2, instead of 2 bromopropane, it is 1 bromopropane. So it is anti-Markovnikov product. Okay, remember it is an Markovnikov product and this one is anti-Markovnikov product. Now this is a reaction of alkenes, but where is it asked? It is asked in preparation of alkyl halides. Okay, so how will you prepare 1 bromopropane from propene? You have to use HBr in presence of peroxide. Remember, it is only HBr which shows peroxide effect. Also emphasize to the students why HCl and HI do not show peroxide effect. Only HBr shows peroxide effect. So these are reasons I'm giving you ideas which you can tell the students. So sometimes the question is propene in presence of HBr and peroxide gives you a product A, and A on Wood's reaction gives B. So if it is HBr and peroxide giving A, which is 1-bromopropane, then the product is going to be, after Wood's reaction, is going to be hexane. So we have to be careful whether HBr is in presence of peroxides or in absence of peroxide. So these are relating things. Sodium and dry ether. This is the reagent that we use often for the reaction, which all of you know is the Wood's reaction. So in the Wood's reaction, this reaction, Sharmishta ma'am will explain to you in detail, but sodium and dry ether is used for, there are three related reactions: Wood's reaction, Fittig reaction, and the third one is Wood's Fittig reaction. Okay, so all these three reactions can be done by sodium in presence of dry ether. Tell them the importance of dry ether. When I tell them Wood's reaction, I also tell them sometimes, see, look at this alphabet, W. It is double U. So when you see double U, you understand U is 2 times. So here the substrate is 2 times. There's a bimolecular reaction of the substrate. So you can, when Sharmishta ma'am teaches you, she will explain this part in greater detail. Okay. Then the difference between NaCN and AgCN. Where do we use this? NaCN and AgCN are used to, NaCN, what does it do? It changes Cl to Cn. And what does AgCN do? It changes Cl to Nc. Okay. So if I take the example CH3Cl plus NaCN, right? What do you get? You get CH3Cn. And here, if I take CH3Cl plus AgCN, right? What will I get here? I will get CH3Nc. Now, one question here is often why with one reagent you get cyanide and with the other reagent you get isocyanide. So please explain to the children why. It is because CN is an ambident nucleophile. Ambident nucleophile. You have heard about this. Ambident nucleophile. So ambident nucleophiles are those which can attach. They have teeth on both sides, so they can bite from the side of carbon or from the side of nitrogen. If they bite from the side of nitrogen, you get isocyanide. If they bite from the side of carbon, you get a cyanide. Okay? And as sir said, Vijay sir said, you should be familiar with the name of the cyanide and the isocyanide here. So this is methyl cyanide, this is methyl isocyanide. The other reason, there are always two reasons for this. One, CN is an ambident nucleophile, and the other is that CN, here NaCN is ionic compound and AgCN is covalent. Okay, so this bond Ag and Cn bond does not break easily. So only nitrogen is available for bonding. Whereas here both sides are available since carbon-carbon bond is more stable. So that is why carbon-carbon bond is formed more easily. So that is for NaCN and AgCN. Then similarly, NaNO2, there are a lot of questions which are asked from this section of alkyl halides. So and this also comes in conversion. So just like NaCN and AgCN, we have NaNO2 and AgNO2. So show them the structure. NaNO2 is like this. N double bond O, this is negative and this sodium is positive. And this is AgNO2, a covalent bond like this, right? Now, if the new bond is formed from the side of nitrogen, then you get nitroalkane. So if I take CH3Cl plus AgNO2, the product that I get is CH3NO2. Okay, the bond is formed between carbon and nitrogen, so you get nitromethane. But in this case, if I take CH3Cl, methyl chloride and NaNO2, then the product that I get is CH3ONO. This is methyl nitrite. So you get methyl nitrite with sodium nitrite and silver nitrite with silver nitrite, you get nitromethane. Why are you getting two different products? Once you explain to the children, they will not make a mistake. So in AgNO2, the bond is formed between nitrogen here and carbon, right? And in NaNO2, when it is, then the bond is formed with oxygen. So that is why you get two different products. So they should be able to do that. Then comes this important, very important reagent, concentrated H2SO4, which we use in many places. So now, since you have finished, you can show all those places where we use concentrated H2SO4. Now, concentrated H2SO4 is basically what? A dehydrating agent. Okay, so dehydrating agent. So what does a dehydrating agent do? Supposing I take ethyl alcohol, it will convert alcohol into what? Alkene, CH2 double bond CH2. Ethyl alcohol will convert to ethene. And this reaction is temperature sensitive. So if I take concentrated H2SO4 and I keep the temperature as 170 degrees Celsius, then the reaction will be formation of an alkene. So alcohol to alkene, how? By having concentrated H2SO4 at 170. But if I take alcohol CH3, CH2, OH plus another molecule of alcohol and keeping the temperature at 140 degrees Celsius, the concentrated H2SO4 is the reagent, but this time the reaction becomes bimolecular and the product that I get is ether, C2H5O, C2H5 plus H2O. So this is diethyl ether. So when I take concentrated H2SO4 at 170, dehydration is from one molecule of what? Ethyl alcohol loses water and you get ethene. The mechanism of this one is very interesting. So sometime, if time permits, I will show you why we get ethene at 170 and why we get ether at 140 degrees. But when you are teaching, emphasize this temperature. At low temperature, you get an alcohol. At 170, you get an alkene. So depending on the alcohol, you will get the corresponding alkene. Then this reagent, H2O and H+. This reagent we use in many, many places. The most important place that we use, and this is, I always tell them, this is a 5-star reaction. So this is a 5-star reagent, which always brings about a very important step in conversion. So what does it do? It changes the cyanides. Okay, cyanides with H2O and H+. The cyanide changes into COOH. The CN group changes into COOH. So cyanides are converted into acids. For understanding, if you explain to the students how it happens, so this is C triple bond N, and when I add water to it, first water adds, you can actually write water as HOH. If you write like this, children themselves will find the answer. Nitrogen is delta negative, carbon is delta positive, hydrogen is delta positive, oxygen is delta negative. So add positive to negative and negative to positive, and you will get the product. So what will you get? CH3, COH and double bond NH. And COH and double bond NH. Now this compound rearranges itself because hydrogen prefers to be with oxygen, because nitrogen, because it is less electronegative. So because of rearrangement, double bond here and H here, it changes into an amide first. So it becomes acetamide. All right. And this acetamide, when treated with more water in presence of an acid, why do we take acid? So that the ammonia which is formed in the reaction does not react with the acid. So you will get CH3, C double bond O and OH. And ammonia which is formed will react with acid and form NH4. Okay, so this is a very, very important step in conversions. When sir takes conversions, he will. So as the time is short, I have already crossed more than half an hour. I will just send you a list of all the important reagents and what they can do rather than explaining it here. So these are a few reagents. HNO2, what it does, it will convert NH2 to OH. Okay, CHCl3 and alcoholic KOH. What does it do? It converts primary amine NH2 group to NC group, isocyanide. This is in the carbylamine reaction. Then come these reducing agents. What does NaBH4 do? NaBH4 is a specific reducing agent for aldehydes only. So it can convert the CHO group to aldehydes and ketones only. So it converts CHO group to CH2OH, and this one will convert a keto group to a alcoholic group. So aldehydes can be converted to alcohols by NaBH4. This is a reagent which can only work on aldehydes and ketones and no other compound. Then you have a next level of reducing agent, which is lithium aluminum hydride. So lithium aluminum hydride, it converts not only aldehydes into alcohols, it can convert acids. So it can convert COOH also to CH2OH. It can convert C triple bond N to CH2NH2. It can convert CHO to CH2OH. Okay, so it can convert many other compounds into the reduced form. So that is why lithium aluminum hydride is, it can convert esters also into alcohols. It can convert acid derivatives also into alcohols. Then this is a reducing agent which can convert aldehydes into alkanes, CHO into alkanes. This is the one which we use in Clemenson's reduction. Clemenson's reduction. Okay, so as I was telling you, the keto group also into alkanes. Okay, so as I was telling you, these are the list. This is a long list. I cannot take the whole thing, but I will just run through this. This is a Wolff-Kishner reduction. This also into alkanes. Then this is a special reducing agent which converts, which is a poison catalyst we use. So when you use a poison catalyst, you can convert acid derivative into an aldehyde. So this is for Rosenmund's reaction. Now we come to oxidizing agents. This is a very strong oxidizing agent. What does a strong oxidizing agent do? It can convert alcohols into acids. It can convert alcohols into acids. Then ammoniacal silver nitrate is a weak oxidizing agent. It's a mild oxidizing agent. So it converts only aldehydes into acids. So if you want to convert alcohols to acids, use a strong oxidizing agent. If you want to convert aldehydes to acids, then use a mild oxidizing agent. Then Fehling solution is also like ammoniacal silver nitrate or Tollens reagent. This is also a mild oxidizing agent, but what is the advantage of this one? It shows color change like ammoniacal silver nitrate, but this also converts only aldehydes, only aliphatic aldehydes into acids. Aromatic aldehydes are not affected by Fehling solution, so it can be used for distinguishing between benzaldehyde and other aliphatic aldehydes like acetaldehyde and formaldehyde. Then you have this copper at 753 Kelvin or 300 degrees. This is a reagent which converts, a very important reagent which can convert alcohols into aldehydes. Generally, when you are converting alcohols into, this is a reagent which we say brings about dehydrogenation. It does oxidation by removal of hydrogen. Okay, so it can convert CH2OH to CHO without the fear of it changing into an acid. So if you want only aldehyde, then you have to use copper at 300. Like CBSE, they use lot of other reagents, but in ISC, only few oxidizing and reducing agents have to be used. This is chromyl chloride. This is used in Itard's reaction. Itard's reaction. So make a list of all these reagents. I will send you what I have on the group, and give it to your children and ask them to learn 5 reagents every day and what those reagents do. Okay. Now NaNO2 and HCl is like HNO2 only. NaNO2 and HCl, what does this do? This can convert NH2 of aliphatic amine to OH. And if it is NH2 of aromatic amine, this is if it is aliphatic amine, it gives OH. If it is aromatic amine, like aniline, then it converts it into N2 plus Cl minus, forming diazonium chloride. Okay. Then Grignard reagent, I will just take a few minutes for Grignard reagent. All of you know this. In conversions, Grignard reagents are a very, very important compound in method of preparation. This is also a 5-star reagent. One question or the other always comes from Grignard reagent. So in Grignard reagent, remember, I tell them there are 7 rules. First rule is Grignard reagent plus HCHO gives primary alcohol. Okay. And second is Grignard reagent plus CH3 RCHO, any aldehyde other than formaldehyde, RCHO. It gives a secondary alcohol. And third rule is Grignard reagent plus ketone. It gives a tertiary alcohol. And the fourth one is Grignard reagent plus carbon dioxide. It gives an acid. And Grignard reagent plus HCN. It gives aldehyde. And sixth is Grignard reagent plus RCN. It gives ketone. And the last is, which we should not forget, Grignard reagent plus water, H2O. It gives alkane. And that is why I saw one question which was asked, why Grignard reagent should be kept in anhydrous condition, because if there is water with Grignard reagent, it will immediately change into alkane. So teach them one general reaction of Grignard reagent and ask them to make all these. They will be excited. They will really do it in a very interesting way. They will like. Then this is another very useful reagent in conversion. We often forget this. I tell them that ozonolysis is like scissors in the hand of a chemist. And the scissors will cut the molecule wherever there is a double bond. So if I have CH2 double bond CH2 and I cut it here, by what? By using ozonolysis, right? So I cut it into 2 parts, CH2 and CH2, and attach so you get aldehydes and ketones. Okay. Supposing you get CH3, CH3, and double bond CH2. Cut it here. As a result of ozonolysis, H2O and zinc dust, you will get CH3C. This is a mistake. So CH3 and C double bond O and CH2 double bond O. Yes. Okay. So, like this, there are a few reactions of ozonolysis. This comes very handy in conversions. Then the next few reagents, I'm not going to talk about them, but they are used in organic chemistry. There are 4 reactions which all compounds with benzene ring show. Tell them those 4 reactions. The 4 reactions are chlorination or halogenation, nitration, and Friedel-Crafts reaction, and sulfonation. So you must show all those reactions when you tell them. Tell them what comes on the benzene ring and where it comes. Okay, so I will take the example of only chlorination to explain. So when I do chlorination of benzene in presence of anhydrous, remember if you don't write anhydrous, then you will not get the marks. So it is very important to write anhydrous and anhydrous AlCl3, and anhydrous AlCl3 will give chlorobenzene. And this chlorobenzene, when it is subject to further chlorination with AlCl3, I will get ortho and para dichlorobenzene. So wherever there is a benzene ring, chlorination can be done with this reagent. So this reagent is for chlorination. Next is one for nitration. Next one is for Friedel-Crafts reaction. So all these reagents should be learned. Now this is bromine and CCl4 and bromine and NaOH. So bromine and CCl4 is used for bromination on the benzene ring, especially when you are using phenol in presence of a non-polar solvent, you will get bromine on the benzene ring. So it is substitution or addition of benzene can be done with bromine and CCl4. But when bromine and CCl4 is also used in Hunts-Decker reaction. If you remember Hunts-Decker reaction. So what does Hunts-Decker reaction do? In Hunts-Decker reaction, bromine and CCl4, it changes it from an RCOOAg in presence of bromine and CCl4, right? It gives you RBr. Okay, so you get an alkyl halide with one carbon atom less. When it is bromine and NaOH, the reaction that we do that Sarmishta ma'am will explain just now, that is Hoffman's bromamide reaction. Okay, so in this reaction, also we make use of bromine. Remember how it is CH3CONH2 in presence of bromine and NaOH. You will get CH3NH2. So you will get, these are two reactions which are done with bromine and here with CCl4 and here with NaOH. They are both, connected reactions because here in both cases, the number of carbon atoms reduces by 1 in the product. Okay. Now these are few reactions which are, which you can show them like this. The active hydrogen is replaced by, so active hydrogen in the substrate and Cl from the reagent you remove as a byproduct HCl, and then you write the product. Then it helps them to find the product easily, otherwise they get lost. Then this is the last bit that I want to show you. I give the children worksheets like this. I will share this with you. You can also give worksheets to practice or to remember or to learn the reaction, like ethyl alcohol. Here you write all the reagents from which you can prepare substrates which can be used to prepare ethyl chloride. Ask them to write the reagents here. Similarly, when you give them the reagents, ask them to write the products here. They can take 1 or 2 printouts of this, and if they write 2-3 times this whole thing, they will not only remember the reagents, they will also help understand the conversion. Say, for example, if I ask you, how will you convert acetaldehyde to diethyl ether? So you should think acetaldehyde can be, diethyl ether can be prepared only from ethyl alcohol. And ethyl alcohol can be prepared from here. So connect them through ethyl alcohol. First use a reagent to convert into ethyl alcohol, then come down, use a reagent to convert it into diethyl ether. So this helps you also in conversion. So this is one way. Here I have given the different conversions of alkyl halides that can be done by using this chart. So that is also one important thing. These are the similar conversions that you can do for aromatic compounds. If you do these charts, you will remember and learn it easily. This is for amines. This chart is for amines. This is another one if the children are getting very confused about this, you can do these types, simple 2 compounds. How will you convert alcohol to this one? So you use PCl5. How will you convert this to here? Aqueous KOH. Okay. How will you convert alcohol to ethene? alcoholic KOH? How will you convert ethene to alcohol? By adding water, H2O and H plus, hydration. Then how will you convert alcohol to an acid? How will you convert alcohol to an acid? By oxidation with K2Cr2O7 and H plus, right? How will you convert acid to alcohol? By lithium aluminium hydride? Okay, so similarly you can have some more like this, and ask them to convert and interconvert only 2 compounds, and then they will be able to learn it better. So this is, I tried to maximize maximum in whatever time I had. So thank you very much for your patient listening. And now you can ask me any questions, and Sharmishta ma'am will then take you through the name reactions.
Yeah, questions. If anybody want to ask questions, you're most welcome.
Hello, Poonam ma'am, can you hear me?
Yes.
Ma'am, it was a wonderful thing like that you have shown us, and very easily we can explain it to the children, especially using those charts. That was
Yes.
something really very good. Thank you so much. The only thing that is there is like when we teach the children, even if we are telling them that this is what the reagent is used for, this particular type of a reaction, after we finish with the lesson or just before the examination, the child comes up with a question, ma'am, how do we learn these different organic reactions? Because
See,
they
this
are
is
studying
only,
not
this
one.
is about, yeah, they are learning so many subjects. I
Because
really,
yes, and we have so many different reactions in organic
see,
chemistry.
you have
Generally,
to,
some of them which are not asked. Some
yeah,
of
so
them are
what you
generally
have to
not
do
asked.
is, yeah, so what you have to do is, see, there is a list of name reactions, but other than that, there are a few other reactions. Just give them that list separately and tell them, see, I've completed the syllabus, so that if some question other than the important reactions come, they should not say we didn't teach. But there are a few important reactions only. Ask them to learn only those reactions. They should be able to learn only those reactions. And also, what helps the most is doing question papers. Only when they start doing, and they should not start learning the reaction during the study holiday of the exam. During the study holiday, they should be only solving the questions. So let them solve.
Yes.
Yeah. So if they do 10 question papers, that is more than enough. So my request to all of you is, all of you make question papers. See, everybody has a style of making. So in our forum, without, nobody judges anyone, without, any hesitation. Whatever question paper you have, please share. Last time when we had MCQs, everybody shared so many, and our children actually benefited a lot from them. I am making question papers right now, and I promise 5 question papers at least based on the new syllabus and the new format I'm going to upload. So you can use them. I'm going to send this PPT also.
Thank you, ma'am. Thank you so much. It was a wonderful thing that you have done. Thank you so much.
What I figured out the problem is, see, now what Poonam ma'am has taught is the entire organic chemistry in the format of conversions, right? These reagents are used in converting one functional group to another functional group. Now, after undergoing all these things, your students are coming and asking, it's difficult for us to remember all these things. Please try to understand, the problem is not
exactly
with this type of questions. If whatever Poonam ma'am has taught now, if the same kind of questions are going to be asked in the board exam, then no student will say organic chemistry is difficult.
Correct.
Or no teacher will say organic chemistry is difficult. The problem is, when you and me teach it in the school, we teach everything like an inorganic reaction. Everything we write with a balancing number and the side products. Why we do that? Because our specimen paper tells us that the reactions are going to be asked like give balanced equations, and the importance is given for the side products. Now, at the end of this session, you should understand the difference between asking the type of questions. If whatever Poonam ma'am has taught, if the same kind of questions are going to be asked in the exams, board exam, no problem for the teacher, no problem for the students. And this is actual organic chemistry. What Poonam ma'am has now discussed with us is actual organic chemistry. But the problem is we are a part of the system. Now my suggestion is, though I am against that kind of questions asking give balanced chemical equation organic, what all the teachers should understand is, because of that one particular type of question, the entire teaching community and the student community is blaming organic chemistry is difficult. Now, you and me who attended Poonam ma'am's session now, this is the core organic chemistry which you and me has actually learned in our undergraduates and post-graduation. If this is the kind of question we are going to ask, see, ethanol changing to ethyl chloride changing back to ethanol changing to ethanol, and ethanol going back to acetaldehyde is never a difficult situation for the kids. Where our kids are losing interest in organic chemistry is when you and me ask them, give balanced chemical equation to convert ethyl chloride to ethanol and ask them to write the side product KCl. If the children is not writing the KCl, you and me are cutting mark, our board is cutting mark for that. Now I am not blaming the board. Now there is no point. We are in this situation. I am trying to tell you that tricks to encounter the challenge. What is that? It is very difficult, okay, to digest, but this is how we need to do. In the beginning, we need to teach like this only. Don't jump and teach all reaction after reaction in the whiteboard or blackboard in your class with ethyl chloride converting to ethanol with the side products. Please teach them what is actual organic chemistry is all about, like how Poonam ma'am has taught, how Sarvisha ma'am is going to teach now. Please teach the same methodology, the reagent chemistry you teach, the naming part you teach, the conversion part, whatever I am going to do, you teach. This is the proper organic chemistry. Then you come and see, this will take some 10 to 15 classes. This is the proper organic chemistry universally taught. World over, this is how the organic chemistry is taught. So you teach them the proper organic chemistry for 15 classes, and then we teach them, let us try to teach the full reaction, side product, N2, 3H2O, 3I2, 3C, 3KOH, all those balancing, memorization type balancing, you teach it later. And Poonam ma'am told one point here, don't teach all the means, don't ask them to learn all the reactions, learn only the important reactions. That is the list what ma'am has put up here. See, through this forum, I wanted to convey this. They are giving us a challenge. They make organic chemistry difficult. How to encounter it? You have to teach them only by this methodology, only the reagent chemistry. Teach them not to write the side product in the beginning, not to balance the organic reactions in the beginning. This we can do at the end of 11th standard itself and prepare them before they start the 12th standard reaction. Instead, what we are doing, we teach reaction after reaction after reaction after reaction. Some 200 reactions we teach and tell the children, learn the reactions with the balancing number and with the side products. Then how come a student can enjoy your organic chemistry? And definitely it is difficult for the teachers and it is difficult for the students. So we have to do organic chemistry like two parts. Organic chemistry for the joy of teaching organic chemistry, first part, understanding organic chemistry, first part. Then the second part is teaching organic chemistry for the examination sake, for ISC chemistry examination's sake, because our question papers are set like that. So it will take a long time, but I am doing that. I am doing two parts. first part for joy of learning organic, and then for scoring mark is the second part.
I really appreciate Vijay sir's point, that he said that we have to teach in, this way. That was the only point that I was supposed to ask to Poonam ma'am, that, I taught them that how the reaction take place and how you are getting the product. But the thing is, this will take a lot of time. And, we know in our school, we do have different other activities also taking place. We don't have this much of time that we are teaching them once through the organic chemistry, what is actually telling us. And then the other way means what are the inorganic products, the side products also. So the lesson division is a big difficulty for us, those who are freshers. I'm just talking about myself. I don't know whether others facing this problem or not. So what is the solution in this case?
See, whatever, whoever it is, whether it is even for fresh teachers, for students, undoubtedly it is a challenging task to teach all the reactions in detail, the way you would like to explain them, and also tell them the way they have to be written in the exam. So what I suggest is there are 25 only, if there are 100 reactions in organic chemistry, there are only 25 reactions which are named reactions, and out of those 25 reactions, I can tell you there are only 5 reactions where balancing we'll have to make them learn because of the need of the examination. So they are iodoform reaction, Wehrmer-Tiemann reaction, carbylamine reaction, Hunt-Stecker reaction, and iodoform reaction. These 5 reactions only, let them learn. And these 5 reactions, if they have to just memorize it, ask them to write it 5 times or twice every alternate day. Or again, like dictation in the beginning of the class, ask them to learn 2 reactions and come and ask all of them to write. It is not impossible. They can do those reactions. Remaining reactions, please, there is no need to emphasize on the reaction. Like for example, see aldehydes and ketones. You need to clearly make them understand only one reaction with carbonyl group. Now, when carbonyl group reacts with C double bond O group reacts with HCN, you get a cyanohydrin. That is what they should remember. What does CN do? Adds on the carbonyl group and gives you a cyanohydrin. Now, if on C double bond O you have 2 H's, it becomes acid formaldehyde. If it is CH3NH, it becomes acetaldehyde. If it is both CH3, it becomes acetone. In each case, the product that you get is the same, that is cyanohydrin. So like that, if you just emphasize on what the addition is taking place, then just give them the list of reagents and ask them to find out what is the product. Make them do it. Don't write the product on the board. Make them do it. If somebody makes a mistake, correct their mistake. Tell them why it is wrong. This cannot be done near the exam. This has to be done from the beginning. So nearing the exam, we have to only tell them what is important and just learn. So there are 10 name reactions which Sarmishta ma'am, I have requested her specially to show how they have to be written, because they come for 4 marks, the name reactions. So ask them to take down notes and learn them. And if they keep learning them from now onwards until January, I'm sure those 10 they can learn. Remaining, you don't have to bother. Remaining, you only have to know what reagent converts to what. Rest of the chemistry questions are only either conversions or identifying A, B, C, D. Only 2 questions are there where you write the name reactions and complete the following equation. Other than that, there is no problem. So you don't emphasize. Just tell them these reactions, I have no choice but to make you learn. But the others, you just understand the reagent and what it is doing to the reactive site and what change it is bringing about. That's all. So that is the way they can probably learn. Yet still it is, however you tell, however we try, the children still are not able to. That's true. But that is the effort that we can make. So distinguishing, they can get marks in name reactions. Out of 10, they will get 4. Then distinguishing test, out of 10, they will get 2. So that makes it 4 plus 2, 6 marks. They will definitely get conversions. If this do some 20 conversions, the way sir has divided them into 7 different types. I'm sure they will do. So they will be able to do it. So from the beginning, don't scare them by telling them all the byproducts. Byproducts can be n number. In fact, when you add HCl to propene, what happens? We say we get 2 chloropropane. But don't we get 1 chloropropane also? Yes, we get 1 chloropropane and water, because 45% is 1 chloropropane and 55% is 2 chloropropane. So that is the whole reason why we are fighting about not making them write the balanced equation, because it is not that like in an organic reaction, stoichiometric reactions, they are not stoichiometric. So don't teach them like that. At the end, as sir said, make them learn the 10 reactions. Which are those 10? Sarmishta ma'am is going to take. So over to Sarmishta ma'am. She has beautifully prepared the slides, and with lot of effort. So others, please see the effort which she has taken with different colors. That will help the children to memorize the balanced equations.
Thank you so much, ma'am. Thank you. Thank you so much.
Yes, sir. Sir wants to say something. Yes.
Kanchan ma'am, I want to add this point. You told about the time frame, right? When I have shared those 75 compounds, which are important compounds to you in the group, means to all the people in the group. I have done all these things during the regular classes. See, they always say this, right? For cutting the tree, you have to sharpen the axe for 11 hours, then it will just take 1 hour to cut down all the trees, instead of directly cutting down the trees. What we are trying to do by this methodology is, you take time. Yes, I understand. Teaching all these things will take time. It is sharpening the axe. After we sharpen the axe, you and me don't have to teach the children the organic chemistry. The children, I took, let us say, some 15 classes for teaching them the basics of organic chemistry. For the joy of organic chemistry, I spent 15 regular school periods. I'm not talking about the special classes, what I do extra. The first 3 or 4 weeks, almost 1 month went only for teaching. Then when I started my haloalkanes and my alcohols, it just took some the same amount of time for completing this. Because by the time I start teaching each reaction, the children themselves, they will not say it is a burden. The children will start enjoying. They will tell the side products. It will not take time. I have experimented it, not 1 year. I have experimented this consecutively for the 3rd year, and this methodology is working out for different teachers. Not only in my school, I have also trained other teachers who have been doing this methodology in their school, where suppose one teacher here, I think in this meeting itself, he has to complete the portion by November 6th or 7th. He asked me, sir, how to teach everything quickly. So I told him, first teach them this. Let it take more time, no problem. At the end of the day, you will come back and do the main organic part later. And it worked out beautifully for him. So I wish every one of us should start practicing this. It is already experimental thing which we are trying to convey to you.
Thank you, sir.
Thank you so much, sir. Thank you, sir. I really want to take 1 minute to just thank Sarmishta ma'am, especially because of her. 2 of my students are in All India rank also. One is Joy Jasmine, other is Ripanjot. And Vijay sir as well, because all the time he was clearing our doubt. The moment we post, any doubt in the group, he just immediately responds. Really, really thankful to all the seniors. Thank you. Thank you, ma'am. Thank you. I'm just eagerly waiting for Sarmishta ma'am's lesson also. Thank you, ma'am.
Yeah, we'll go ahead with Sarmishta ma'am now, and we'll keep all your questions for the end. We will stay back as long as you want and answer all your questions. Sarmishta ma'am, over to you.
Yes. Now, the point which I wanted to share, mainly, Poonam ma'am and Vijay sir said so many things. Everything Poonam ma'am told that, means I am really blessed to have to attend today's program, because the way she taught, I think in 22 years, I have not discussed in this way organic chemistry. And really the way it has become so simple, so freshers definitely will gain a lot. And that is the reason why Vijay sir said that we overburden the students, because from last 22 years, I am working in the council as a ISC for ISC corrections. And every time that balanced chemical equation, the children lose their marks. And it's very difficult when I come back after the correction to explain my children that why should we learn balanced chemical equations. So in fact, in my all the reactions, in all name reactions, I have balanced it. And maybe that is a defect which I teach in that way because I'm used to in the council. But Poonam ma'am, I would request you and Vijay sir and even Anand sir, these type of sessions we should really frequently, after 15 days, we should have, so that our children get really, means we teachers, if we are benefited, then automatically our children will also be benefited a lot. I haven't mentioned the detailed mechanism, etc. of it. Rather, I just wrote about that a silver salt of a fatty acid. First, I teach them about the monocarboxylic acid. As Vijay sir, everywhere he mentioned that we make a lot of, like we have to work a lot about the nomenclature part. So Hans-Dicker reaction, which is a silver salt of a fatty acid, a monocarboxylic acid, when it is treated with, heated with bromine in CCl4. So maybe I just explained them what is the role of CCl4 here. So it is giving me a bromo alkane, which is one carbon atom less. My main point is to teach them that it is a decarboxylation reaction where one carbon atom less. The bromo alkane which is prepared contains one carbon atom less than the parent acid, the silver salt of the acid which we take. Then I give any example. Sometimes if I have mentioned here as propanoate, I do mention it clearly, 3 carbon atom. I go to the nomenclature, and in this way, sometimes I feel that I waste a lot of time. And one thing very important besides this name reaction, which I want to explain, that Vijay sir gave a very correct explanation. Recently, one of my colleagues in my school only started nomenclature. I think within 2 days, he gave so many difficult examples with 10 carbon atom, 9 carbon atom complex branching, that the children were very, very scared of organic chemistry. So they forget what is propionate, what is propanoate. So first of all, 1 to 5 carbon atoms, we should make them clear. Okay, so next I move to the carbylamine reaction. Here I mentioned clearly about general reaction. Sometimes children prefer general reaction, that is they want that we should mention, we should clearly explain them about the alkyl group, aliphatic, aromatic, primary amine. So sometimes I take here time in explaining that if it is a primary amine, secondary amine, tertiary amine, quickly then slight, maybe 5 minutes I give them in the nomenclature part, but with easy examples. So it's a carbylamine reaction where we are getting where we are heating a primary amine with chloroform. And as ma'am said, alcoholic word is very important here. I haven't written the bond here, but I don't pressurize them to write RN triple bond C. Sometimes they may make a mistake, especially the below average ones. But yes, I definitely explain them that an alkyl isocyanide is prepared or a carbylamine is prepared and it is alkyl, how to name them. And of course, I wrote the balanced chemical equation, as Vijay sir said, 3KCl and 3H2O. But yes, sometimes the name reactions, if they are not balanced, the council doesn't give marks. So I would request Poonam ma'am, when you say, you gave me definitely 10 reactions, but there are 25. So please, once again, in the group, mention so that we are very clear with our students that these many reactions they have to study. At least the children will be, it's a great relief. The children will be relieved and relaxed, so less reactions they have to memorize. So this particular reaction is a characteristic test of a primary amine, a diagnostic test. You can say that the primary can be easily distinguished with secondary and tertiary. Secondary and tertiary amine, they do not give this test. Nowadays, they don't ask, but earlier, I think in the board exam, we used to get nitrous acid test for primary, secondary, and tertiary amines. But I think nitrous acid test they have removed, and they made us Hinsberg's test or maybe carbylamine test. This will help in the test also. Next, for aromatic amine, I wrote that primary amine, aniline and phenyl isocyanide, phenyl carbylamine, so resulting in the formation of an offensive odor of carbylamine. Then in haloform reaction, I think I wrote quite detailed because haloform reaction is like iodoform reaction. It starts from haloalkane, haloarine only. From haloalkanes, we teach them chloroform and iodoform. I did not mention about here bleaching powder, the way in the lab we taught them how ethanol was prepared and how acetone was prepared. I simply wrote that this particular reaction has a widespread, like great significance of haloform reaction, mainly aldehydes and ketones. I mentioned about the methyl keto group, and I mentioned about the sodium hypohalite. So I mentioned because I wrote haloform reaction. But when the children are asked about iodoform reactions, especially in the council exam, then for that, it's a different slide which I have prepared. Let me first come to the haloform reaction. So the children should be very clear that sodium hypohalite is a mild oxidizing agent, how it is prepared within the reaction mixture, how it is prepared in situ with a halogen when treated with an alkali. So amongst aldehydes and ketones, amongst aldehydes I wrote only acetaldehyde gives this haloform reaction because it possesses the methyl keto group. That is, the keto group is present on the second carbon atom. Other aldehydes doesn't give this test. So I mean, in fact, haloform reaction with this test also I'm explaining. Almost all methyl ketones, because they are, if they are, the keto group is in the methyl ketones, as I said, keto group is in the second carbon atom, is on the second carbon atom. Almost all methyl ketones give this reaction. So when sodium hypohalite is formed, it halogenates it. First, the oxidizing agent will be produced, and then it will undergo halogenation, and then it will undergo subsequent hydrolysis, resulting in the formation of iodoform or chloroform or whatever it is. But it depends. If we teach stepwise, explain them the proper way, and then again we have to make them memorize, or we have to make them learn a little bit of the iodoform reaction, what are the raw materials used, and what is the main product formed. If the major product, if they come to know, then I think balancing won't be a difficult task for them. Here I have mentioned iodoform test in the name reaction also, because it should go simultaneously when we will explain the test part, iodoform reaction, that it is characteristic for the compounds containing methyl keto group, that is CH3CO group or CH3CHOH group, because it alcohols also give this reaction. And when alcohols are giving this reaction, ethyl alcohol, sometimes the children ask, my students asked me that alcohol, why C2H5OH gives the reaction. So I then explain them that why C2H5OH gives the reaction, because this alcohol is getting oxidized to an aldehyde with the help of this mild oxidizing agent, and hence the aldehyde further contains CH3CO group, and so it is able to give you a positive iodoform reaction. I also taught in my school, when I teach them stepwise reactions, sometimes as every point I remember, as just now in this workshop where Poonam ma'am said and Vijay sir said, sometimes it is the children are overburdened with so many reactions which we write on the blackboard. That's very true. This time in 11th, I will use the method what ma'am said, but I don't think so. This can be used in 12th. In 12th only we can brush them up and revised. With the revision, at least till January, I think I'll be able to manage with my regular school, but taking extra classes. Online, I have to take extra classes for refining them. So here sodium hydroxide, caustic soda is treated and giving us sodium hypohalite. X I have mentioned already, I think in the theory part, that it is chlorine, bromine, iodine. Then I mentioned here, then I made it clear also to the children how it gets halogenated, whether it is with iodine or chlorine. Then the same thing on hydrolysis gives me a tri-halo alkane. But here, when we add these reactions like this sodium hydroxide, the first reaction, this is can be cancelled out, this can be cancelled out. In this way, if we multiply the first equation by 3, then automatically 3NaOX will be cancelled with this 3NaOX. As a result, we'll get here 6NaOH. 6 and 1, 7 NaOH will be towards your left hand side. There is 3 NaOH towards your right hand side. So 6 NaOH, 7 NaOH and 3 NaOH gives me exactly 4 NaOH. That means when I will add these reactions, the child will automatically come to know that this final reaction is this, that if a ketone is warmed with alkaline solution of iodine, it gives me if it is iodine, I mentioned here iodine, but there is a mistake here, teachers. I mentioned here X, it should have been CHI3. Please overlook my mistakes. I wrote here haloform. The another thing which is very important for a student to know, that the acid which is formed, often they keep asking me that if it is aldehyde, then what will be the salt which is prepared? The salt of the carboxylic acid which is prepared should always contain 1 carbon atom less than the original, the parent compound with which we started. If we have started with aldehyde, CH3CHO, we'll get HCOONA, sodium formate. If we start with the propanone, that is CH3COCH3, we'll get sodium ethanoate. Then I just wrote in short that ethanol, isopropanol, yes, as sir mentioned in the common name, very important that we teach so much nomenclature, but at the end, in class 12th, again, they are very, very weak in their IUPSC, in recollecting what is the raw material, as sir said about acid anilide. Same way, when we tell them isopropanol, they are often confused what is that isopropanol is. So several times I have seen that whenever I take up a class, again iso, neo, secondary, tertiary, we keep explaining them. And I think in one of the board exam, pentane 2-on and pentane 3-on was asked. Distinguish, though that is not in the syllabus, that was not in the syllabus, but that was a very long many years back. But it was discussed that the children should have been taught about methyl ketones. So pentanone 2 will show a positive test for an iodoform, but pentanone 3 won't. What is the reason behind? Then iodoform test I here mentioned, though in distinguish between also, I'll mention it, but that is a very short form. Iodoform test is a very diagnostic test. When I explain iodoform reaction and haloform reaction in detail, I explain them about the detection of iodoform test. Mainly earlier we used to teach in this way. Nowadays in specimen paper and in Farooq sir, which when he explained in our meeting was little different, but I teach my children in the same way, that name of the test is very important. The reagent used is very important. Framing it in the language is not that important, but the main thing is iodoform test is important. Alkaline solution of iodine is important. What is the observation is important. That is whether it is a yellow precipitate, whether it's a crystalline, not crystalline, but yellow precipitate is important. And a negative test also I teach, that is important. The children should know that this particular compound, like methanol and ethanol, I'm saying, ethyl alcohol and methyl alcohol if they ask me, formaldehyde and acetaldehyde if they ask me. So I teach them that does not respond to this test. Sometimes the children write no reaction, sometimes they write like a negative statement, but they should be taught that that does not respond to the test, that does not show the test. Next, Riemer-Tiemann reaction. When I'm explaining about Riemer-Tiemann reaction, especially some of the children prefer a single step reaction. I avoid single step reaction. First, I teach them the detailed step, and then I come back to the single step reaction. So when chloroform is heated with phenol in the presence of aqueous, the word aqueous here, the state should be mentioned. There's no hard and fast rule for the numbering, penalizing them, but aqueous KOH at about 333 to 340 Kelvin. Here I mentioned 60 degrees C, teachers, but there I mentioned in Kelvin. So that's not a very important point where the children will be penalized. But yes, orthohydroxybenzaldehyde is formed. Here again, balancing is an important point. But I may first teach them in this way stepwise, that what happens when phenol, stepwise, separate I teach. What happens when phenol comes in contact with NaOH, how sodium phenoxide is formed, that is the acidic nature of phenol I teach, where hydrogen is released. Then I teach how chloroform reacts with sodium phenoxide and how this CHCl2 that gets substituted, and from where that HCl, they keep asking about the byproduct, how miss you got this. So separate, again, the same thing I taught. Again, when I used 2NaOH, I taught them why we are using 2NaOH, so that this chlorine will be replaced by OH. And when this chlorine is replaced by OH, what about this 2Na? So this 2Cl, which will be liberated out, can be a byproduct here. Then again, they should know, because we teach them monohydric, dihydric, trihydric alcohols. That time we make it very clear that the two hydroxyl groups on one carbon is unstable, so it will give me an aldehyde. So as a result, I get an aldehyde with the sodium with phenoxide containing an aldehyde group in the ortho position. I think here I mentioned that it is here somewhere I mentioned that it is a carboxylation that is in salicylic acid. I think I have mentioned the COH group is introduced in the in the ortho position. Similarly, here an aldehyde group is introduced in the ortho position. It depends on the temperature. Then here I did not use the word acidification. That means when it gets acidified, here ONA will be converted into OH. So ultimately I get 2-hydroxybenzaldehyde, that is salicyl aldehyde. Orthohydroxybenzaldehyde, here I mentioned it as the major product. Similarly, I did not mention, teachers, I will definitely send you, as ma'am said, that I'll prepare everything and send you that carbon tetrachloride, when it is in the same case, when phenol is treated with carbon tetrachloride and caustic potash, it is giving me salicylic acid, orthohydroxybenzoic acid. Often phenol is converted to, when I think sir will deal, when he'll deal about the conversions, these important points should be known to them, as they get phenol to salicylic acid, aspirin. Then in Kolbe-Smith's reaction, here I mentioned about the carboxylation, I think, in the ortho position. Phenol, a spelling mistake here, sorry for this. Sodium salt of phenol, when treated with carbon dioxide at a low temperature, means carbon dioxide at low pressure, temperature, if it is high, para isomer will be the main product. But when the temperature is 400 Kelvin, then ortho will be the main product. In that detailed mechanism, I don't explain, because some children, a handful children are interested, and in council, yes, as ma'am said, reaction mechanism, the way beautifully she presented extremely well, that should be, we should really teach in 11th. And that I also, maybe, as I told you, 22 years I have taught so precisely. I think I have not, I was not that successful in, conveying this method to the children. My children will be very happy after Diwali vacation when I'll talk to them about the concise method, so simple and lucid way organic chemistry can be taught. So sodium salicylate is the major product, but it on acidification is giving me salicylic acid. Here I tried to mention that sodium phenoxide, sodium salt of phenol treated with carbon dioxide, it forms intermediate, and then on rearrangement, it gives me, that is the carboxylation takes place. So it gives me a sodium salicylate, which on acidification, here byproduct I did not mention, which on acidification is giving me 2-hydroxybenzoic acid, that is salicylic acid. And here I just mentioned that para-isomer can be formed, though it is never written along with Kolbe's reaction, but I just mentioned that at a higher temperature, this can be formed. Another main important point, which often my children write, and I do correct my copies, means I don't give them marks. That is, sometimes they write sodium phenoxide, and on the arrow, maybe Poonam ma'am and Vijay sir will give me an idea that if I am wrong, then I'll rectify myself. But this exam, half yearly, I did not give them marks. On the arrow, they write everything. That is CO2 they write, and maybe the temperature is not that accurately mentioned, and pressure not mentioned maybe accurately, and they write the word coal-based mixed reaction. And finally, they come to the product. So I did not give them marks because as usual in council, we did not give them marks in case if it is a balanced chemical equation, though this balanced word I have not come across in the specimen paper, but still to set in conversion, I think it is still applicable, sir will teach us. But I think in name reaction, we should not write in one word the complete name of the reaction and specify the product. Then we come to aldol condensation. Of course, I don't know, I'm not so very accurate in this PowerPoint presentation part. So there are many flaws in my notes maybe. So please overlook, and I'll rectify it if the team is there with me and so learned group is with us. Aldol condensation, I have mentioned here clearly. First of all, I teach them with the alpha carbon because they are very much confused about that alpha hydrogen and alpha carbon part. So here I did not mention that detail, but I think in Canizaro's reaction, I have mentioned it clearly by just a minute, if I am able to recollect it. I think here, like just a minute, here I mentioned them clearly what is alpha carbon. That is a carbon atom on which the functional group is attached. And then I mentioned them what are alpha hydrogen atoms, though we are supposed to teach hyperconjugation, there we are supposed to teach, but as ma'am said, Poonam ma'am said, that during COVID online classes, hardly the children understood. So my present batch of 12th, I have often seen the reaction mechanism part is very weak. So maybe that alpha part means that was missing, that they don't, very rarely they understand. Though Seitzeff's rule, I made them very clear during dehydrohalogenation, what is that alpha, beta, gamma. But still here I mentioned clearly that what is alpha carbon, where it lacks, no alpha hydrogen atom is there in case of Canizaro reaction, formaldehyde and acetaldehyde. So here I come again. In aldol condensation, I explained them that these, the reactants, like it is a self-condensation. I have not discussed teachers crossed aldol here. Self-aldol condensation, that it's a self-condensation where dilute alkali is very important, and a self-condensation is giving me beta hydroxy aldehyde. So where is that beta? What is that aldehyde? And main thing is a very important point which they often make a mistake, that is I feel they write 2CH3CHO and write dilute NaOH, though mechanism is not asked. So that much hard and fast rule should not be there. But still I accept it in this way only. And propanol 2 moles, dilute alkali, giving you diacetone alcohol. They may write IUPAC name, but diacetone alcohol they should know. Beta hydroxyketone. Achha, one main important doubt which I also have, I mean, I don't teach, but often the children immediately right after beta, in aldol condensation, they further heat it with a mineral acid and make it alpha beta unsaturated aldehyde, and they give me an answer with an alpha beta unsaturated aldehyde. But I think according to me, I don't know about difference. Opinion will be there definitely, but aldol is only this much. Not, I think in aromatic aldehydes we still can, because the product formed is little unstable. In aromatic aldehyde, I did not show crossed aldol. Aromatic and aliphatic means benzaldehyde and acetaldehyde. There we can still, the product is not that stable. So on further heating, it gives me alpha beta unsaturated aldehyde. But in this case, aldol is this, and the student should write till this when aldol condensation is asked. I explained them formaldehyde does not, and like in the give reason, I think in some of the papers in 2018, 19, 17 board papers, they have asked about the Canizaro reaction, about the aldol condensation, about the alpha carbon, alpha hydrogen atom and all. So they do not show aldol condensation. Why? Then we come to, 1 minute. Canizarose reaction. Here, I have not taken up cross-Deltol, but definitely I'll share my points that in cross-Deltol, children sometimes make a mistake of same aldehyde, and that I'll mention when I teach cross-Deltol. Let me just finish it. Canizarose reaction shown by those aldehydes which do not have alpha hydrogen. But unfortunately, in both my slides, I think I have mentioned about benzaldehyde. I rectified it in the next. So I teach the word disproportionation. We teach redox reaction, but still we explain them about the disproportionation reaction. And we teach that how one molecule is, I should have written one thing, that is 2 moles, which is missing here. Benzaldehyde 2 moles, so that one molecule is oxidized at the expense of the other, which is reduced. And when the one molecule is oxidized, another mistake which I have mentioned, I'm so sorry, here I have written Na, whereas the caustic alkali I used, that is caustic potash I used, but I have mentioned here Na. I said, please excuse me and forgive me for the mistakes which I have made. So it will not be forwarded to you. I'll rectify and forward it to you. This K, it should have been K here, potassium benzoate, not sodium benzoate. 50% concentrated solution of KOH should be mentioned, or concentrated KOH should be mentioned. Then the equation for Canizarose reaction, since both the slides have benzaldehyde, here I mentioned about formaldehyde, where formaldehyde, one molecule is oxidized to methanoate, means sodium formate, that is sodium methanoate, and the other is reduced to methyl alcohol. Then next for benzaldehyde, I have mentioned, already I have mentioned, again the same mistake here, KOH I mentioned here, and this was sodium benzoate. I'll rectify it. Then we come to Rosenmund's reduction. I mentioned many points actually. Preparation of an aldehyde from acid chloride. So when we mention about acid chloride, especially when I'm teaching about acetaldehyde, I should mention about the common name and IUPAC name of that acid chloride which I'm using. And though I use the word, it can be used for the preparation of both aldehydes and ketones, but I did not mention in my slides about the ketones, because by Rosenmund's reduction, ketone cannot be prepared. Correct. That is by dimethyl cadmium separately. Here I mentioned Rosenmund's reduction, aldehydes which can be obtained by the catalytic hydrogenation of acid chloride. I use the word catalytic hydrogenation specially. It's not required, but mainly I specified it because sometimes the children mention nascent hydrogen here. That is not allowed. Nascent hydrogen, because we are writing acetaldehyde can be obtained by passing hydrogen through a solution of acid chloride, which is in boiling xylene. And we are poisoning the catalyst, that is especially by addition of sulfur or quinoline. We are poisoning it so that it further restricts the reduction to alcohol. So here I mentioned that barium sulfate and sulfur poisons the palladium catalyst and it checks further reduction. Formaldehyde cannot be prepared by this method. Definitely methanoyl chloride is unstable, or formyl chloride is unstable at room temperature. This I mentioned especially because a lot of in board correction, I have observed that whenever the children write nascent hydrogen, they do not give marks. So maybe I mentioned it specifically that nascent hydrogen it's not a chemical reduction, it's a catalytic hydrogenation. So nascent hydrogen should be used. Then Hoffman's bromamide reaction, where there is a degradation reaction, means very helpful for descent of the series when we explain the children about specifically the conversions. A primary amide, that is RCONH2, when it is heated with bromine and caustic potash, it is yielding a primary amine containing 1 carbon atom less than the parent amide. It's also termed as degradation because the product which we are getting contains 1 carbon atom less than the parent compound from which it is prepared. Next, reactions I mentioned both for aromatic and aliphatic, that it's an alkanamide, that is where R is ethanamide or acetamide. Very rarely I mention ethanamide, but sometimes some children ask me about the IUPAC names because sir is very true, Vijay sir, that common names are mostly asked in the exam paper. So they cannot, at that time they are unable to correlate what ma'am taught and what is asked here. My children in 2015 or 16 suffered because of that acid anilide, many children. So CH3CO and H2 acetamide, when it is treated with aqueous KOH and Br2, is giving me a degraded product that is 1 carbon atom less. Again, a decarboxylation reaction. It's giving me methanamine, 1 primary amine, 1 carbon atom less than the parent amide from which it is prepared. Same way, benzamide, which is giving me aniline in Hoffman's degradation reaction. Woods reaction, ma'am, I think you told about the Woods fatigue and fatigue. I think I missed out that Woods fatigue and fatigue reaction. I just wrote about Woods reaction where a symmetrical alkane can be prepared from an alkyl halide. I remember last year, I think Corey-House synthesis was not included in 11th, but still I taught because children sometimes are unable to correlate, and conversion it is still allowed, but I think when we are talking about symmetrical and unsymmetrical, the children should know about the yield where it is more. So Woods reactions, symmetrical alkane, the yield is more as compared to unsymmetrical alkane. I think this is the last slide for the name reactions. Definitely Woods fatigue reaction where toluene is prepared. Methyl benzene rarely asked, but the word toluene is very important, where we use again sodium metal in the presence of dry ether. Again, that importance, as ma'am said, every time we should correlate why we are using these reagents and what is the use of that, so that they can correlate about the metal used in the presence of dry ether. And in fatigue reaction, it's a diphenyl or biphenyl. That means haloarine, 2 chlorobenzene molecules. When it is heated with, warmed with sodium in the presence of dry ether, we get biphenyl. Fatigue reaction I have missed out, and Woods fatigue I have missed out. The name, the distinguish between is, should I share distinguish between, ma'am, just now? The distinguishing test, should I proceed with my distinguishing?
Yes, ma'am, you should go ahead.
No, sir, Vijay Kumar, sir, you do conversions first. Distinguishing people will manage if it is extra delay. So you introduce the conversions, though. That is also the 7 points, sir, which you said, you mentioned those. And distinguishing tests we can post,
Yes, ma'am,
on the group.
Yes.
That is better.
My point is, since we are trying to do everything, we will go ahead with the plan. I think with just 15 minutes left, I cannot start and complete the thing, man. Like the practical session, whatever we have done, we can make it into two parts. But it is not that we have to complete everything by today itself. So if Sarmisha ma'am could complete the thing one day, Anand, if you do, Anand, I agree. I mean, you agree with me, I think.
Yeah,
we can have.
Just let me know when. Weekend is not a problem.
So then we can do conversions. You mean we can do conversions on another day?
Exactly. So because we need to tell all our fellow teachers about all the important points, whatever we have discussed.
Right.
Okay. So the whole conversion I will
So
make it in
with distinguishing test, after distinguishing test, we can conclude. You mean? Yes. So, so before we start, Sarmisha ma'am, I wanted to just say a few things, a few tricks which we can do for remembering which name reaction. See, one is I always tell them ABC reaction. ABC reactions are aldol, benzoin, and canisero. So aldol, benzoin, and canisero can be learned together. And, you can compare, like in aldol, there is alpha hydrogen. In canisero, there is no alpha hydrogen. Aldol can be shown by both aldehydes and ketones. Canisero is only by aldehydes. And benzoin comes in between, where it is shown by aromatic aldehyde, and the product is somewhat like aldol. Not aldol, but somewhat like aldol, because it has a carbonyl group and a CHO. OH group, both are present. So that is one. The other point I wanted to say is that, we don't have in our syllabus, I have never seen a aldol condensation or propanol being asked, but when if anyone writes down that product, propanol, and does not take the alpha hydrogen, then the answer is wrong. So you still make a aldol, but that is not a true aldol. The true aldol is one where the two carbon atoms which are having a CHO group, carbonyl group, and a OH group should be separated by one carbon atom. So if in a MCQ you are given 4 aldols and you have to identify a true aldol. See, aldol is a compound which has a CHO and a OH. But if a CHO and OH are separated by one carbon atom, then it is a true aldol. Okay, formed by aldol condensation. Then you were asking about, see, the word aldol formation is followed on heating by condensation. Condensation word, why does it come? Because there is an elimination of water. So there's no harm in writing alpha beta eliminated product as a final product. Sometimes you write, sometimes you don't write. Depending on the question, you can decide what to do. Similarly, you can also decide the name, divide the name reaction in another group, where the name reaction depends on the product which is formed in the reaction, like iodoform reaction. Why? Because iodoform is a product. Carbylamine reaction. Why? Because carbylamine is a product. So that is how they can associate. Then some are, of course, based on the name of the scientist, so you can't do much about it. But like that, we can just give them a few hints. Many times children confuse between Schwartz reaction and Finkelstein. Okay, so I tell them Finkelstein starts with F. So F is not used in this reaction. So Finkelstein is one where we don't use fluoride. So in Schwartz we use fluoride, in Finkelstein we use iodide. So like that, some small things, if you tell them, they are able to recall the reaction better. Okay, now ma'am, about distinguishing tests.
Hello, I would just like to ask that the points which a child needs to mention in a name reaction during the ISC exam, if those can be spelled out once more.
See, the points which should be there, one, it should be a complete equation. Whether we like it or not, the complete balanced equation with all the byproducts should be there. That is point number one. Then, depending on how the question is framed, you can write the name of the major organic product. Major organic product like iodoform reaction, you should mention iodoform. You need not mention the observation. In many cases, name reactions are associated with observation. But observation need to be mentioned only if it is a distinguishing test. Otherwise, just writing the balanced equation is enough. Sometimes the question is, they say, what happens when acetyl chloride is reduced in presence of Lindlar's catalyst with the help of hydrogen? Write the reaction and name the reaction. So you write the reaction and then identify the name of the reaction. So sometimes name reaction is given, you have to write the reaction. Sometimes you have to write the name and write a reaction, then it carries 1.5 marks. So, Mr. Ma'am, are you ready?
Thank you, ma'am.
Excuse me, ma'am. Good evening, all of you.
Yeah.
Ma'am, what
Yes.
about mechanism? What about mechanism?
Mechanism, see, so far, I have not seen many questions on mechanism.
Yes.
There are few mechanisms mentioned in the syllabus, like the mechanism in some places, like SN1 and SN2 reaction is mentioned in the syllabus. So whatever is mentioned in the syllabus, only those mechanisms. I think altogether there are 4 mechanisms mentioned. Those mechanisms only you need to teach them. But I have not seen a question directly like they ask you about the mechanism of esterification, but that has never been asked.
Yes, ma'am. Thank you.
Similarly, somebody had put a question on biomolecules, how to make them learn biomolecules. Let me tell you, there are only 4 mark questions from the whole chapter of biomolecules. And there are only 10 possible questions which are asked from biomolecules. Just write those 10 questions, make them learn the answers, and that's about it. Teach them, but to learn, let them learn those 10 questions. Only questions from there will be asked from biomolecules. If you see previous year's question papers, you will understand only the same questions from biomolecules. Let them not start learning detailed structure of maltose and sucrose and all those things. They should only know the names, alpha D glucose and beta D fructose, they form sucrose. That's it. No need to draw the structure. So biomolecules also, if time permits, in the next class, we'll do something on biomolecules.
Distinguishing tests I have mentioned in this way, like if they are asking us, as I told you, I think equation they should like practice, but then equation is not a hard and fast rule, I think, to write down in distinguish between, but they should know at times if the child is unable to write the product, the name of the test, and here if the child is writing iodoform. The board has asked us acetaldehyde and formaldehyde. The correct answer is they should write about the name of the test, that is iodoform test. Iodine in alkaline medium, that is the reagent used. Acetaldehyde is giving us yellow precipitated iodoform, which is the color observed and the precipitate. Formaldehyde does not show this test. In case if they are unable to write anything and if the equation is there and the names are there in the equation, especially iodoform word if it is there, alkaline solution of iodine if they write, I doubt they write, but in case if it is there, then the equation is will help them to get the marks. Similarly, if it is acetone and acetaldehyde, then Tollens test, best way to failing solution or Tollens test. So they should know about, means the ammoniacal silver nitrate is the Tollens reagent. Acetaldehyde forms silver mirror, that is the keyword is the silver mirror on the walls of the test tube. Acetone does not show this test, and as usual, in the balanced chemical equation or in the equation list, we are studying acetaldehyde, giving you acetic acid and silver mirror is observed. Similarly, when they ask you about formaldehyde and benzaldehyde, so failing solution, because benzaldehyde gives silver mirror with Tollens reagent, but benzaldehyde does not give with failing solution. So when treated with failing solution, formaldehyde gives a brick red precipitate. The word brick red is important. Failing solution, that is the reagent, is important. Benzaldehyde does not show the test. Formaldehyde gives a positive test. For formic and acetic acid, very important for us to know that when we are writing about here, just for a second, I may take a break here. Formic and acetic, I remember sometimes children in ethanol and acetic acid or something like acetaldehyde and acetic acid, they write here acetic acid gives iodoform test. So they are confused CH3COOH. They think that CH3CO group means acetic acid gives the iodoform test. So that also point sometimes we need to specify. So formic acid and acetic acid, as such, formic acid is a unique acid which contains an aldehyde group as well as a COOH group, carboxylic group. So ferric chloride test with neutral ferric chloride solution, acetic acid gives a wine red coloration, formic acid does not show this test. Wine red coloration, very important, and it gives us a brown precipitate on heating, but no need wine red coloration, that's fine. Sometimes acetic acid and benzoic acid is asked. If it is asked about acetic acid and benzoic acid, then benzoic acid gives you a buff colored precipitate. It's a precipitate, it's a coloration. Wine red coloration is shown by acetic acid, but benzoic acid will give you a buff colored precipitate. So there's a difference here. Tollens test, treated with ammoniacal silver nitrate solution, formic acid forms silver mirror because formic acid is showing the properties of an aldehyde as well as an acid here, but aldehyde here specifically. Acetic acid does not show this test. So distinguishing test is, if one test is there characteristic, this is the best test. Oxalic and acetic, I think oxalic acid is this time not there, but we can easily take acetic acid wine red coloration and finish it off. We know oxalic acid, the children will be able to write because we are doing the titration redox with KMNO4 and oxalic acid. So they know that it decolorizes KMNO4 purple color. Acetic and benzoic, as I said, already mentioned, buff colored precipitate with benzoic acid. Urea not there, so I'm not mentioning about the biuret test. Ethylamine and aniline important, bromine water test. Aniline gives bromine water test, white colored precipitate is formed. White colored bromine water, ethylamine does not show this test because both the amines show carbonamine test. Primary amine, aromatic primary amine, aliphatic primary amine. So we cannot write carbylamine test. Ethylamine, diethylamine, definitely we can write about carbylamine test because this is characteristic test for primary amine. An offensive odor of carbylamine is obtained. An obnoxious smell of carbylamine is obtained. Correct? Then we come to glucose fructose, very important bromine water test. Fructose does not show this test and glucose decolorizes bromine water. Ethanol and tertiary butyl alcohol, yes, the children should know Lucas test as ma'am mentioned clearly about the reagent, and there only primary, secondary, tertiary alcohol should be mentioned, and the student should know. Sometimes I feel that in one of the papers in Kanpur only, some teacher asked about 2,2-dimethyl 2-chloro-2-methyl propane, something like that, and then the child could not 2-methyl propane to all, yes, propane to all. So the child could not distinguish whether it's a tertiary alcohol or a secondary alcohol. So tertiary butyl alcohol, when it is treated, this gives instantaneously the turbidity. So the reagent should be mentioned, and turbidity at room temperature does not show this test. Sometimes children write ethanol produces turbidity at a high temperature. Wrong. I mean, it should not be written because both cannot give. Here we should write one negative, one positive. Ethanol and phenol, you can write about the picric acid, correct, about, or you can also write about nitration with concentrated H2SO4 and HNO3, means this the nitrating mixture should be concentrated HNO3 and H2SO4. Ethanol does not show this test, or iodoform or azodye test. Here I have not mentioned, I think, but azodye test, coupling reaction. When we circulate that coupling reaction notes, that time I will mention about the azodye test. Ethanol, glycerol is not there, but you can very well mention about, glycerol is there in the organic practicals. So acrolein, that is the smell which we get with potassium hydrogen sulfate. Ethanol does not show this test, but glycerol shows, gives a characteristic pungent odor. This can also be tested with sometimes Tollens reagent, as I have done in the lab sometimes. That acrolein was not clear. So I got it done with to show the students that glycerol is aldehyde, showing the Tollens test. Then when glycerol, this is the best one, simple and best. 1-propanol and 2-propanol iodoform test. Propane 2-ol shows iodoform test, CH3CHOH group, and does not show the test. In alcohols, only ethanol and propane 2-ol shows the iodoform test, as well as the equation. Then formaldehyde and formic acid, we cannot mention here any other test because both of them shows those, the test, mainly this one is better. The best, that is formic acid, because formic acid is an acid, so brisk effervescence observed with sodium bicarbonate, and formaldehyde does not show the test. This turns lime water milky. Then I think only these many tests I have prepared today, not more. Anything else, ma'am? Ma'am, you just mentioned, the main things, the mistakes which I have made, because first time I also have presented those name reactions, and also with your experience, you just rectify me as well as others. You are mute, ma'am, I think.
Poonam ma'am, you're on mute.
So that only they should make sure that when they are choosing a particular test for distinguishing test, there should be a proper visible observation.
Yes.
Either a characteristic smell or a color. Like sometimes children use aldol condensation for distinguishing test. They cannot, because their aldol doesn't have any characteristic color or smell. So we have to choose only those particular reactions which have characteristic color and smell. Okay. Now two parts of organic chemistry remain. One is give reasons and the other is conversions, which is very, very important. And sir correctly said that it is not possible to cover conversions in a short period. It is a whole topic by itself. Similarly, reaction mechanism is a whole topic by itself. So we'll do a few more classes whenever it is convenient to everyone, and hopefully it will help.
Kanchan ma'am is asking some question.
Yes.
Yes, ma'am. Thank you so much, ma'am. But I have a query, ma'am.
Yeah.
See, ma'am, if, for example, a student is not writing observation, rather is only writing reaction, will he
No, you
be
won't
getting
get any mark.
credit?
You won't get any mark.
No marks.
Right. Right, ma'am. Thank you so much, ma'am. Thank you, Sharmishta, ma'am, for this really encouraging and really beautiful session.
Thank you
Any-
for coming.
Thank you all for attending this for almost 2.5 hours. It was really nice to be with you all, and please keep posting your doubts wherever possible. We will be able, wherever we can, we'll definitely help. And wish you all the very best for this year. And I really hope our children, all our students do well. We are here all for our students only. So God bless them all and God bless you all.
Thank you, teachers.
Thank you so much.
Thank you, ma'am.
Yeah, if there's another session coming ahead, we will let you know. As always, we have the WhatsApp groups. So
Kanchan ma'am has a question again.
Yeah.
please ask, please.
No, sir. I just forgot to unraise my hand. Yeah. No questions here, ma'am. Thank you so much, ma'am.
Okay.
Thank you.
Okay then.
Hello, sir. Anand
Yes,
sir. Anand sir.
yes.
Anand sir, for conversions, would we be having another session like some other day or something like that?
Yes, sure.
Because I think conversations are very important part for
Yeah,
the
they are.
council examination.
Actually, more than all these things which we have done.
Yeah,
that
I
is
think
a major
conversion is
part.
the most important.
Yeah, most
Yeah,
important.
because
We
that would
definitely-
also, because conversions will also include like, identification of ABCD type of questions,
Yeah,
which are
we'll
also
do
a part
that
of conversion.
Just
We'll
now,
do that. Yes.
ma'am, just now,
And
Suparna Banerjee
and-
ma'am posted one thing. Yes. Suparna Banerjee ma'am said a very important message she posted, that is, this recording should reach us as early as possible, especially with
Yes,
Jester
it will
and your
take at
session.
least 1 week. It will take 1 week.
Because
But we will,
I will-
all of us will post our individual PPTs on the group. The whole recording of whatever we have spoken will be available in at least 6 days' time. Because it requires, the
I can say that. So it takes a lot of time to painstakingly go through and edit out the parts. Yeah.
yes.
So that's why it takes time. So I can post it only after that. Just it depends on how much time I have. So I think by next Sunday, I think you should have it.
yes.
I have a question.
yes,
Vijay sir. To Vijay sir, sir, I'll take your personal help that this teacher whom you helped, that to finish the syllabus by 6th November, I have to finish my syllabus by 10th November. So I'll definitely.
it is very difficult. It's very difficult.
Karthik sir is there. He can tell his views on that actually.
Yes, Karthik sir. Well, I just saw him. Definitely. No, I'll come back to you and disturb you. Definitely after this session.
Good evening, ma'am.
Acha, he's Karthik sir. You helped him out to finish. So I'll now take his help.
Karthik sir, would you
Yes.
please unmute? Yeah.
Thank you, Anand sir.
Yeah.
Good evening, ma'am. Good evening, Poonam ma'am. Good evening, Vijay sir. Good evening, Sharmista ma'am. Good evening, all. So I had a difficulty in completing the portion. Actually, by November 4th, I have to complete the portions. And I had alcohols, phenols, ether, aldehydes, ketones, carboxylic acid, and nitrogen compounds. All three major topics. I completed only haloalkanes and haloarenes and rest of the parts. Then I seek Vijay sir's help and I asked him how to do this. But I'm not getting any extra classes, the same timetable, whereas except math, all others completed the portion.
Every school,
physics.
I think the same. Physics, chemistry teachers never, physics and maths teachers never have any problem in finishing the syllabus. But I don't know why.
Yes, ma'am. Sharmishta
maths
ma'am,
are,
you're exactly right.
Yes.
Every time
Because
they think
in our
that
place
chemistry
also
teachers
physics
are
and
inefficient. As if.
And there's one more thing with chemistry. The reason being, like, our marking scheme becomes very difficult because when I go for corrections, comparing marking schemes, if I hear what the physics teachers tell us and about maths teachers, the children are able to score much more. And when it comes to chemistry, our marking scheme is so very difficult that every small part of it, also the child loses marks.
Sheetal ma'am, I have been for correction for many, many years. Yeah, I am personally of the opinion that in physics, I was physics for 15 years. I taught in an ICSE school, IC. I think that the correction in physics is very liberal. And unlike Vijay sir, I can happily say that I'm not part of the council anymore. So I can go up in arms against them, no issues. Yeah, I think it is extremely and ridiculously liberal, giving away marks for just about every unnecessary thing. Okay. So, I have a point of difference in that. So I think see, if you want to improve the education system, you can't just throw away marks. One has to, it's a very, very difficult area to deal with. Then our children, if we are very strict with them and we don't give them, they will lose mark. What about people from other boards? So this whole thing is a very messy affair. I think the best answer to this question is you make sure your children are well prepared. That's, I think, the only answer that you can have it. So, yeah.
Yes, sir.
Okay.
Yes, sir.
So after Vijay sir's help, I have completed organic chemistry, almost done. That is, I completed all the important things. First, what I did is I completed all the organic compounds which are that is the students will be facing in ISE board. That is 70 plus organic compounds. I made them to study the IUPAC structure, IUPAC name and common name. And I kept a test, 2 tests in that. So first 35 compounds, 1 test, next 35, altogether totally 70 plus compounds, 1 test. So I almost more than 90% of the students were thorough with the IUPAC name and common name. And I insisted them where the IUPAC name should be learned, for which compound the common name should be learned. So after this, the students were thorough with the 70 plus compounds. Then after this, my part was almost easier. So then I went to the type of reaction that are available in organic chemistry, almost 7 plus type only, 7 types of reaction. So in that 7 types of reaction, I introduced the reagents also with the help of Vijay Kumar sir. So with each type of reaction, what are the reagents have been used in those each type? And with that, almost the conversions also coming. So this 7 types of reaction is done, almost 60-70% of your thing is over. Then after this, we'll be moving on to the 1 carbon conversion, then 2 carbon conversion, then 3 carbon conversions, then increase in 1 carbon, decrease in 1 carbon. So likewise, the last one is aromatic conversions. Like this, all types of conversion has been done. So now after finishing this, what I did is I gave the specimen question paper to the students and I told them to answer the organic questions without my help. Everyone did. Everyone did. They all did the conversions without my help. And they all are very confident that they will score more than 25 plus marks in organic chemistry. Till now, I didn't touch the chapter. I didn't enter the chapter. I taught only haloalkanes and haloarenes. But they are very confident. Just before, by Thursday only, I completed this part. Now they are very much confident. And right now I'm having the whole previous year students notes. So I'm having only 10 days. So now I'll be teaching the alcohols next week. By Wednesday, my school reopens. So 4 days, I will try to complete it with whatever period I'm having. Then the next week, I will concentrate more on carboxylic acid. 2 days, I will concentrate on nitrogen compounds. So once I done this, they are having their seniors notes also. So it's done. Now itself, if I say the portions are over, they are happy because they got the confidence that we will score more marks in organic chemistry. Only small touch-ups are there, so that we will, next 10 days, I will finish it. Thanks to Vijay
Very
Kumar sir.
important.
You can
Vijay sir?
buy Karthik sir, you can buy a cake and post it to Vijay sir, I think.
Vijay sir, no, not at all. We will now contact Karthik sir and Vijay sir. They will switch off their mobile. We will so many times disturb them. How to now finish, how to now finish. Confidence in organic, if the child is having this, means great achievement.
Yeah.
Yes, ma'am.
So just the trick is just focus on the important and the basic principle. That's all. You don't have to
After
teach
knowing
them
these
very-
conversions, ma'am, they are enjoying and they say how beautiful the
enjoying.
organic is.
Hmm.
And I
Correct.
didn't teach about the side products. I only concentrated on the major product form. That is, it is just a conversion of one functional group to another functional group. That's what
Yes.
we taught.
So it is only about, knowing the 25 formulae for doing thousands of numericals in trigonometry. Same way, 25
Same way.
reagents and what they do. That's all. And then you have to just permutation and combination of that.
In fact,
Very interesting.
Karthik's words is actually setting the base for this organic chemistry. He has experienced it and he has used it. Kanchan ma'am has asked a question now, how to complete the portion. Here is a
Yes.
witness for that. You
Yeah,
can,
but,
once you,
ma'am, where is
I think
she?
sharpening the axe is more important. Please remind that.
Ma'am, here I am.
Yeah.
Very important. This is a, like you can say, a very important example in front of us.
So we,
Yeah,
now
I'll also contact Karthik sir for the same, ma'am. I'll also disturb him and
Yeah,
Vijay
my
sir
pleasure.
as well.
Anytime.
Really, now Vijay sir will be free because he has already trained sir. So now we will be after him. How to really, I mean, children
Anand
enjoying
sir,
chemistry
I
is not-
have a query, ma'am. Sorry to interrupt. I have a query, Anand sir. Will there be any session for reasoning questions also?
yes.
Right, ma'am. Thank you so much, ma'am. Thank you so much, seniors. Thank you for brushing up, your freshers. Thank you. Thank you so much.
Okay. So shall we
Yeah.
close?
Yeah.
Thank you so much, Anand.
Thanks. Yeah.
All this was possible only because of you. So my really,
And
from
in
my
fact,
heart,
I'm
God bless you.
really blessed,
And may we have many more.
thankful
Like
to all of you.